Hello. How's everyone doing today? Just getting started straight out here because I think today's stream's going to be jam packed. I got a lot of topics to talk about, not least of which talk about the new stuff that's going on with Astro. But yeah, I've been touching on a lot of reactivity stuff, which led to me doing like a lot of theorizing that I've been going over the last few weeks. I got updates on that stuff. Seeing the Astro demo actually got me really inspired, and I actually prototyped a whole bunch of prototypes this week, trying different things with just playing around with web technologies. So I want to talk about that a bit as well. So very cool stuff. If you're joining in, come say hi in the chat. Chat is kind of barren right now. I'm gonna go advertise this on Twitch right now so we can get this started. All right. Yeah, stuff's starting to come in. Hey. Yeah, it's one of those like midsummer afternoons, probably one of the hardest times, but I'm hyped about this stream. This one should be a good one. Yeah, exactly. Yeah. So I've tried to watch a little bit of content other people were putting on server islands, but one of the benefits I had on this one was I got to see the article and the stuff before it came out. So like day before, I was sitting there like playing with it and being like, okay, like Brian's take of it, right off the bat, which gave me a little bit more time to think about it and get pretty deep on it and talk to Matthew. That's how I ended up inviting him on the stream today, because I was kind of like playing around with it. And Fred was like, man, you have a lot of thoughts. I'm going to actually pull in the developer who actually worked on this, All right. How's everyone doing? Yeah. I've been working on a lot of stuff around async and Derive stuff. The thoughts along those paths have been continuing on. But I think there's like sometimes, and I can admittedly say this about HTMX. Sometimes like there's ideas that come across that are kind of left off the table because you're like, okay, that doesn't do everything I want. But the trade-offs show at least one aspect that is incredibly compelling, and it causes you to rethink like generally everything else around it once you kind of put that together. Sorry, my stuff's a little quiet right now. Sorry, yeah, rethink everything around it. So I think server islands is an example of that. But yeah, where was I? I was gonna share the channel on Twitter or X. I can never get used to calling it X. I'm just old, I guess. I'm going to talk a bit about this today because we've been talking about PPR a little bit on stream, and I'm like, I don't get it. But I also never built anything, like I was just like, okay, whatever. I was like, okay, I theoretically, I like can see slight gains, but I actually I don't really think it, like, I can see the gains with the approach of going straight to the CDN. But once you have some kind of edge work or something in the way, basically proxying the stuff, then like it's streaming at the edge, right? So this week I actually built stuff to finally have an actual opinion about PPR. So we'll talk about that a bit today as well, right? Because there's actually you've got PPR versus server islands, but there's actually like a third category, which is just like stream render dynamically from the edge, right? Next was very vocal when they came out being like PPRs because the edge failed, right? And I mean, this is a spicy one here, but I don't know if the edge failed or just Vercel's edge failed. So this is an interesting thing. We'll talk about it as a bit more later. What does PPR stand for? Is this one of those like only wrong answers? I mean, I'll explain what PPR is in a minute, but chat, feel free to give the interesting answers. Sorry, let me share my screen for a second. Make sure that it actually works. You never know. It hasn't actually been that long, has it? All right. Let's view quote. No, not view quote. Let's just quote tweet it. Live with. I made one mistake on my tweet. I didn't tag Matt talking, and I didn't tag Astro, which is like this terrible marketing loss here. Bam. All right. And then we'll let those people get past the TWiJ pre-roll so we can get started here. Pay per render. Yeah, that's not a bad answer. Yeah, partial pre-rendering. Yeah, that's the actual answer. Okay. But I mean, even that, it's another 3-letter acronym, and that doesn't probably mean anything to anyone. Does anyone out there know what progressive rendering means? Just putting out there that for a long time, what we call out of order streaming was called progressive rendering. Like you go back to older articles and stuff, they called it progressive rendering. Anyway, I think we're about ready to get started here. I just want to give people on TWiJ a chance to join in. There's only 8 of you over there right now, which is surprisingly low. YouTube's doing a little bit better today, but TWiJ is a little bit on the weak side. So let's see if people will come in and join on. Right? All right. Yeah. There's no like conference today that I'm not aware of or something. Some like hidden React conference. All right. Getting everything going. No. Yeah, no. I know chat isn't strong, but the viewership is. There's only I only got a handful of viewers on, a couple handfuls, I guess, of viewers on TWiJ compared to YouTube right now. Hey, yeah. Let's get this one. See, usually I drag a lot at the beginning, so people are gonna miss out on prime content here. Few and the mighty. Is that how it works? Okay. We're starting to ramp up. Okay. Yeah, I guess everyone else is gonna have to check this out on the replay, because, as I said, in some ways, this is kind of a small feature that probably wasn't too hard to implement. Like it was challenging, but not as hard as some things, and definitely not as hard as implementing PPR. But the impact of what it represents, in my opinion, is actually huge. Do you mean ramble? Yeah. Thank you. All right. Let's get started. Without much further ado, let's welcome Matthew onto the stream today. How are you doing?
Hey, how's it going? Thanks for having me.
Yeah, no, it's good to have you again. This is your 3rd time, I think, joining me on the stream.
I think so. Yeah.
So hopefully people are familiar. The first stream we did was what? It was on
Core set, probably.
Yeah. And then we did the Astro 3 launch stream where we got to show the world not partial pre. The other one.
View transitions, right?
View transition. Yeah. But doesn't that one have a cool 3-letter transition?
I don't think so.
Yeah. What doesn't?
Oh, I don't know. There's NPA view transition. I don't know what you're talking about.
No, I was just like, no, I'm saying that it didn't. I'm like, why doesn't that one?
No,
have
yeah,
a
no.
acronym? Then
yeah,
it's joining. It's missing it. But it's interesting because the one commonality here. Well, I don't even know if it's commonality, but Astro's been really pushing people to rethink how they look at what is modern web development. I mean, I've been showing a few of your tweets even on like my This Week in JavaScript. I think there was like a couple weeks ago. Let me see if I can find it right now. Where you? Oh no, it was actually only a week ago. No, it was a couple weeks ago. Let me find it. Oh yeah, this one. Let me share my screen for 2 seconds.
Oh,
Yeah, I mean, this is a little bit out, but you've been like, I mentioned this with Corset, obviously before, but you've been. I think even the way you view Astro at times is different than even say I view Astro. Or other people view Astro sometimes. Like when I see comments like this, you've been thinking about ways to shake up, like even beyond the work, that directly ships in Astro, where there's like the happy path where people are like, okay, I have my Astro page now, I put my React components on it. There, I don't know. I get the impression that that you're like thinking beyond putting React components on your Astro page or whatever. I don't know.
Yeah. I mean, I think a lot about that. Yeah. I mean, I think about like what's next. I think about what are the problems with, the component paradigm, and like what would something different look like. I think about that a whole lot. Not really related to Astro. Astro is a very practical framework that people use components. So like we let you do that in the best way possible. I do sometimes think about how Astro could, go another direction. Not another direction, that's the wrong way to put it, but like try to implement some of my ideas in a more practical way. Because when I think about it, being pretty impractical. So yeah, I do think about these things a lot.
It's the reason I find that interest is not just your own. I've seen a few other projects from people around the Astro community, things like X-Element and stuff like that, where they're kind of challenging like how far you can take the Astro template syntax itself. But yeah, I understand it's a separate thing, but I am, the reason I'm bringing this up is for a good reason, because I think there are more possible ways things can go than what we're sitting and looking at right now. And while you could say some of that stuff might be even kind of outside the practical part of, what, Astro puts as like what you're good at. I think that in small ways, Astro nudges people that way often, even if it's like not like the necessarily the happy path they're thinking about. Like Astro supports for partials in HTMX, right?
Yes, we have partials.
Yeah, which is again a feature where, I mean, some people might view this as almost a primitives kind of approach, but it's tricky in a landscape when so many parties are trying to control how things work, so to speak. So yeah, I don't know. This actually makes me think of another tweet you wrote here. Where is it? The one you did last week.
Surprising me with all of this.
Yeah.
A lot of this is just like I'm frustrated with something, and like I just tweet something out and don't think too much about it. Oh, was this one? Yes, yeah, that is, yeah. I do think that. Do you think that? Like, I don't know if that makes sense, but I mean, I just look at like what everybody is doing about trying to make it easier to communicate with the server, like breaking the server client divide. It's really that communication between the two, like making it not feel like the same app in terms of like all the codes the same necessarily, but that communication is like very simple and like very direct.
Yeah. No, I mean, this one, I'm not going to admit, when you put the last post about the components, I was like, yeah, I'm not giving up components from an authoring standpoint. But this one I latched on to right away because, I mean.
So give up components. I think, so what I mean by that, like it's the composition of components. It's like I have a component, and the way that I compose my app is I pass props to other components. That doesn't mean you don't have JSX or templating or something like that. It's just like maybe the communication between those things does not happen through props. It's really props is the thing that I've been thinking about.
I see.
As something that maybe we could do away with that. Like, what if you created an instance of a component like outside of the template, and then you use that instance? That instance is the thing that is inside your template, and you communicate it through, whatever, message passing, for example.
Why does this makes me think of MVVM a bit.
Yeah. Well, it's how do you break the component architecture is like the thing that I think about. Like, I guess I feel strong. Well, first off, I don't think component architecture is perfect. I think it has like some pretty deep flaws that are hard to overcome. And I'm not sure that like incremental progress is ever going to fix those things completely. So like we either end up with a place where like, we like components because they make it easy to compose DOM, but like composing state kind of sucks. And we got to go all these sideways channels and, you know, do all this weird stuff to try to like, you know, because it's all about preserving components, right? Like that is like, if you think about fetch overriding, it's all because like you want to fetch in the component like that, the component is like the central thing. And so if there's ever going to be a paradigm shift, then I think that has to break, because whenever there's a paradigm, there's always a central thing about the paradigm, like the thing that you're thinking about, like where your mind is. And today it's components, obviously. And if there's going to be something else in the future, then like components have got to change. I don't know if that makes sense.
Yeah, I mean, it does feel like something that we've been dancing around. Like the reason I brought up MVVM is because in that model, the templates were very much separate, and the templates included templates, and then the view models included view models, and then the models included models. And there's like this kind of three-way dance where the data was driven through the models. The view models mapped them with like, because I guess the challenge is there's always ephemeral state or temporal state that exists arguably in the components, and then there's like other stuff that is more persistent that lasts longer. And one of the challenges for that, at least from my perspective, has always been like the very, very first JavaScript frameworks in the client didn't account for ephemeral state. They were like trying to take MVC patterns from the server and bring them straight across. And then you got like Angular, like I think it was called like ng scope or something, where they like had to kind of like sneak in this like localized kind of state, because there was no concept, because they had controllers, not instance based stuff. And then like Ember was a bit like that too, a little bit. It wasn't that bad, but Ember just added more types of things. Like Ember would be like, we have containers and controllers and so it's like, I mean, obviously I can't completely take what we've done in the past, like, because in a sense the component model had been done to a certain degree, I think, in the past as well, before it came back around for like with
back
React.
In the DHTML days, there was like component like things,
right? So like the component one's a tricky one, because it does, like, for me, I feel satisfied enough understanding two things about components, that like not components, or sort of the UI pieces don't necessarily have to, like, data trees and UI trees are not one for one. So as long as you accept that, like as long as state can live outside of the component, that's the first piece. But yeah, data fetching and async is tricky, because even with that kind of acknowledgement, I'm one of the biggest proponents of hoisting, which is again pulling it up or pulling it out. Local data fetching isn't a real thing unless you have a compiler that pulls it out, but then it's still pulling it out. So like, compiler is the last thing I think about. The first thing I think about is mechanically how this thing should work.
Exactly. Like compilers, like people like rush to try to solve problems with performance problems with caching, and that's hilarious because we're talking about caching today. But like that's people's first instinct is like, I'll throw a cache on it. But like making the algorithm as fast as possible is the first step to performance. And the same way. Oh gosh, I lost my train of thought. What were you just saying? I was trying to make
talking about hoisting, data fetching.
Yeah, I mean, hoisting is
obviously, and using a compiler using a compiler.
Sorry. Yes, compiler has to be like the last thing. Like, sure, you can kind of fix stuff with a compiler, but there's the same way that caching we got to invalidate the cache. Like compiler has the same sort of issues where the compiler has limits, especially in a dynamic language like JavaScript. So I like to think about like, what is the more fundamental problem?
Right.
And if I can avoid compiler stuff, I would like to do it, because I don't know. I don't think that leads anywhere. I just think there's limits, I guess, to
Yeah,
that.
it's an interesting contrast or because sometimes compilers can, almost like a new language, dramatically change the way people look at the problem enough that like it provides this kind of change in the way you view the problem enough that it's like worth it. A perfect example is for me is like Svelte 3. Like Svelte 3 is incredibly simple. I can't think of a like, or not simple, easy. I
Is
can't think
Svelte
of like
3 is that the change to the single file components? Is that Svelte 3?
Yeah, that's when they went to single file components and lets
Okay.
are reactive and $sign labels and like the Svelte that everyone knows basically. Before that, they had the .get and the .set and all that stuff. But the one where it's just very straightforward language. And it wasn't my thing because, you know, skepticism of compilers to a certain degree, but I could see people just picking up and being like, look, let count equal 0, count plus count in HTML, and it worked. So it was an example where it was drastic enough, you know. And I guess another example might be like any DSL where you can like express an idea straightforward. I know you were a big fan of DSLs to a certain degree, like when you were working on Corset. So like there's that level on the compiler, but then there's like sometimes the danger of that is there's always like a possibility that you miss. Like you're like you might design the language too narrow, and you need more flexibility. It might be fine,
which usually happens.
Right. But then on the other hand, like then there's the compiler. Like I guess I have an interesting opinion. Like Svelte 5, I love Svelte 5 directionally because it's finally doing the stuff that I want it to be doing. But on the other hand, the benefit of the compiler for Svelte 5 is more suspect for me, at least personally, because it's a difference between, say, calling a function and not calling a function. Mechanically, what's happening is a function is being called, but the compiler is just hiding that detail, and it doesn't actually affect the mental model. You still have to kind of explain to people that it's calling a function. So like that's where the like, for example, for me, like the compiler stuff, like similarly with data hoisting, when you have to tell the people that it's getting fetched above. You can't actually hide the fact. It's like it's like compiler for convenience. It's like syntax.
But that's important. Getting back to like what I was saying, that is very important for component architecture, right? Is like you want to be able to think in the terms of a single component, and when you have to start hoisting data and stuff like that, then now you have to start thinking a different way slightly, and the whole thing kind of breaks down. That's why I think Vercel next, or the React team has gone to great measures to like try to protect like the component based thinking. You know, overriding fetches exactly that as well. I don't trust a compiler to hoist correctly. Like as a user, I don't like writing JavaScript and being like, am I allowed to do this? I don't know. Like I need a list of rules. Like the editor doesn't tell me that I'm not allowed to do this thing, but I guess I'm not allowed to do it. And I'll find out when it compiles to like bad performance, I guess, like, right. And so I'm not against compilers in general. I think if you design a language with constraints, then it makes a lot of sense. Like you have rules. Like I want, as a developer, I want a list of rules. Give me the rules and let me stick to it. Not the sort of like, we're like subsetting JavaScript so you can only do these certain things, but they're kind of written down into very loose terms. Like, I mean, at least the rules of React, the hook rules and stuff, like pretty simple to like keep in your head, right? Not
it's funny.
necessarily simple to obey all the time, but it's simple to keep in your head.
Yeah, I never actually had like that much issue with React taking the approach they did with hooks initially, like just because they were very clear at the onset. And I think this has been a shift because, and I mean, I guess I gotta credit Swix with this one. I don't always want to credit him, but he wrote this article like 4 years ago or 5 years ago where he was talking about the shift left in development, and you were talking about your IDE. Like if your IDE could give you the feedback early enough, like then maybe you might be more okay with it. It's kind of one of those things where like you know, that's why TypeScript's so popular, right? Because it's like the ultimate linter.
Yeah.
And like in the same, we're going to see lots of different compiling stuff. It's why React has strict mode, which obviously annoys people to hell. But sometimes you wonder, like, if the framework, if we knew now what, like, or we knew then what we know now in terms of like what should be strict mode, like how would we design stuff differently? So we would have just started with the assumptions that we have in strict mode, today, and then people wouldn't have go through that pain because of the migration to it. But then like maybe everything would be cleaner, but sometimes less intuitive, because sometimes you end up with like React set state, which has a very good reason for not setting the value right away, but literally drives people crazier than it should. Even knowing that rule, like it's one of those funny ones, So like we're going to see more and more of these compiler type things. Obviously, React might be a game changer, right? Mentioned here. I mean, I did a stream on Forget a little while ago. It was fun. I think it was important for people to recognize what Forget did versus what it didn't do, because a lot of compilers have two sides. And I've written about this kind of dichotomy before. It's kind of like electric cars are really good because they're efficient in a certain way. They're good for like gas economy. That's why you see them on like the light, cheap cars. But then on the other hand, because of the efficiency, you can actually get more performance sports cars out of the electric cars, as we've seen with Tesla. And I think understanding sometimes with compilers, they're aiming at one side versus the other side, not necessarily like, or maybe shoring up both sides, but not the whole thing. I mean, I don't know if it's a great analogy, but like Forget is very good at making it easier for people to write React, is the best way to put it. It doesn't actually change the characteristics of like React itself, how it runs. So it's like, it's one of those interesting kind of things. And I think I'm going to try and pull this all the way back. I think it's interesting as we add more of these tools and pieces, the perception of like the complexity, because no one here in this whole stream, probably listening, watching, or whatever, is going to claim that they know exactly how React Forget works. Unless we get the core people joining on like they did last time when I did the stream on it. It's very unlikely everyone's going to understand like all the details of it. But the further away we get from the underlying platform, and the more that we're aware of that gap, the more perceived complexity there is, and that's something that is interesting to me, because it's a perception thing, because everything is a little bit complex, but the complexity, the perception of that complexity is very important for how people like come in the developer experience and whatnot. And I think one thing that continues to be true over and over again is the perception of the complexity around Astro has been consistently something that is very, not only straightforward to get started with, like on the easy side, but also keeps things relatively simple or transparent. I
mean, that's for a number of reasons. Like, kind of the opt-in design is a big part of that, right? Like, there's no like, oh, we'll figure out where your server islands are. You tell us with the tag, and that's obviously client components the same way. I think that's a big part of it.
Sorry, I was laughing. Ben Holmes self-promoting a little bit. What's going to happen to Ben's suspense library, right? I saw this a little while ago. Ben did a kind of like a demo where he was doing like something like out of order streaming in Astro a while ago.
He built a library for it. I don't know what's going to happen to Ben's suspense library. I don't know if he's trying to say he wants it to bring it into core, or he's like, now he doesn't like it anymore. I'm not really sure what Ben thinks. I think it's pretty cool. Like, I don't know, like, is it? I thought that was cool that he could implement that as a library. I don't know if that means we did something right, or if that's just normal. Like, could you do that in Solid as a library?
I mean, I got to think about it. It's tricky. tricky-ish because do you know what it takes? Acknowledgement of, you need to be able to read, if it's actual suspense, not just like await components like say Svelte, you need to acknowledge where the promises come from, which is tricky. So if you communicate it in promises, then I think so. Yeah, it'd be a little convoluted in Solid to do it. Like the stitching in the streaming is easy. I mean, we'll talk about this with server islands. It's not too hard to stream in script tags to swap in HTML content. But
no, it's not.
But what's tricky about stuff like Suspense, obviously, is like handling the detection of the async, and knowing how to handle it. Like, I guess in Solid it would be weird. Like in React, you throw and then you could percept, or maybe even Astro, you can just go re-render it again. And I guess technically we could do that on the server. Someone could write code to do that, but it's like we really try not to re-render stuff. So it's like it makes it a little bit tricky, or a little bit different. I think this is actually an interesting side point for people to think about, but like in one way, people talk about async coloration, right? Because like now everything has to await, you kind of propagate it throughout the tree. But reactivity systems are fairly, I don't want to call them, like, it's not coloring the same way they color functions, but like once you're in reactivity, you kind of got to stay in reactivity, which is why reactive systems usually aren't compatible with each other. And so like one benefit of React conceptually is that they're like, we don't really care. It's a half lie because they have their own internal state mechanism, but they were trying to say like, we don't care about your reactivity of your data. You can just trust us to re-render again. So you can kind of see that like simplicity in play in an example like this, where you're just like, okay, you can always tell React to re-render again. If you can catch a promise, then you can tell it to re-render again. It's a little different with reactivity systems where they're like, the data is specialized, like, and in those cases, you almost need the data to be, it's almost like it's a primitive. It's like language level primitive. You need it to be part of the language, essentially, to actually be able to describe these things using reactivity. So, yeah, sorry, you probably didn't expect this to be such a long answer, but it is one of those interesting things where reactivity might not color functions, but it's, was it invasive or... pervasive or whatever it is.
Something like that.
Right.
Infectious. Infectious, is that word?
Right.
A little bit.
So like, he also invented Ben and Jerry.
I've been thinking a lot about like how you could structure a framework. I've been working on a framework, I should say, but let's not talk about today. But I've been thinking about a lot about how could you get a lot of the same benefits you get from frameworks, but without any sort of reactivity, without actual reactivity, without any sort of like reactive data. So no signals, no hooks, and that sort of thing. Because that's the part that I tend not to like about it, is the infectious part. And like anytime you want to do something, like you need, like there's a million JavaScript libraries out there, but if you want to use those in any sort of framework, you wind up wanting to like wrap them in order to make them reactive and that sort of thing. And I don't know. I think it's interesting just to think about, at least, is that if you were able to just have plain regular variables, plain regular properties and whatnot, like that would because that's it's a big problem creating your own framework, is that it's the ecosystem. Like at the end of the day, no matter what you do that's special, 99% of people care about the ecosystem. And if you were able to like build something that could just use the entire JavaScript ecosystem, and like it felt native, however that works, like that would be a big benefit. So anyways, that's kind of sidebar.
Yeah, I mean, it's tricky, right? Because if the native stuff is built with events in mind, like if the basic JavaScript stuff is built with events in mind, then it can be mapped to reactive systems fine. But the challenge is, like, when you were first describing it, I was like, okay, so you want React, like, just, or Preact or whatever, because they have this like just render it approach, but that requires diffing, right? And I mean, the diffing could happen at the DOM level, perhaps, but like basically, if you don't have special data, you end up updating more than you need to, so you end up diffing, which then is tricky.
No. Well, I think So
unless
yeah,
it's events.
okay. I agree. You probably need diffing if you don't have specialized data. I'll agree with that. But what if a component, whatever you want to call it, is very small, right? Like if you don't need to like diff all that much, then it's not a big deal, right? So can you create a system where, you know, you have these like little pieces of things that are communicating with each other, and you know, sure you're diffing them, but yeah, it's you're not diffing that much. Maybe in practice you wind up diffing a lot, because actually when you do change state, you do wind up having to, you know, message something else that changes state. So maybe it doesn't work out in practice. I don't know, but that's something to think about.
And it's one of those things that like I'm also kind of wondering how much about the like what people think about when they think of sites or websites. Perfect example of this is when we were talking about server islands, and at first, you know, we're talking about it, and I came to a stark realization that I've never professionally built, like I've worked on framework level teams in this scenario, but when I was on product teams doing web dev, I never worked on any site where the LCP wasn't dynamic. So like, and I know that seems crazy. I'm positive everyone.
So you've only worked on like social networks and
networks and like CRUD kind of apps and like call center and dashboards and
dashboards probably. I don't know. You could, I guess you probably wouldn't use server island. So are we going to get into server islands?
Exactly. Yeah, exactly.
Should we define what it is? Does your audience already know like what it is?
Some of them do, but I think we should keep it pretty general here first. So yeah, let's introduce server islands. I'm gonna first, I guess, maybe pull up the blog post so that I can see it, and maybe you can first tell people from your perception, what are server islands, since you were instrumental in implementing them for Astro. Yeah.
Okay. So I mean, just in practice, if you understand Astro, you know what a client island is. You add client : load, idle, etc., and Astro will render that on the server, but also in the client, basically rehydrate it. So it's just a way to do rehydration, for you. It's kind of a declarative form of rehydration. Server islands are kind of the same sort of concept, but for the server. So you mark a particular component to run on the server, and it will run that in the directive we use is server defer. So you're deferring the page, you're deferring that particular component to run after the page loads. So that's kind of like how you use server islands. But what it really is a way to differentiate types of content to run at different times, to load at different times. And the primary reason why you might want to do this is it allows you to, think about a web page, and you have different pieces of it which are more dynamic than the rest. We use the term static versus dynamic. That those terms are kind of, there's a lot of in between on those things, but you can think about like you have highly static content, which is like your shell, the shell of the page, the header, etc. Then you have some parts that are like more dynamic, which for something like an e-commerce is the product itself. But even in that case, those things don't change all the time. Like maybe if you're Amazon, you're changing products every second, but for like most e-commerce sites, you're not.
The listing page for like a specific product, that if I was like I don't know, if I was like looking for green shoes, I don't know, I won't look at green shoes, but like these pages that pull up when I go from a search listing, these pages do not change very much. Doesn't matter if you're Amazon or whatever.
So go to one of those and just stay on it for a second. So
I wanted to see if I could find eBay or Amazon. Here's one, Amazon.
Okay. Yeah, Amazon, like they have different constraints than the rest of the world. But
apparently I can't click it though. Maybe odd. Why did it just decide that?
It's like can't selecting the text. Yeah.
Okay. Whatever. We're gonna go to Adidas.
Okay. Yeah. So yeah, obviously here, like when we say static, we're really talking about everything except for like the login pieces. So we have like that header up there. You have a cart. You have like an avatar. They're not showing an avatar there, but you know, a lot of sites do. Obviously, those are the parts that we're considering dynamic. So what server islands allow you to do is it allows you essentially just to cache different parts of your page differently. And in this case, we're assuming the comments, those are dynamic, right?
Right, exactly.
But the product itself is not. So you could set a cache header for that product for, I don't know, once an hour, like, you know, cache it for an hour, or you cache it for longer if like you don't change your products all that often. You know, you can kind of have that flexibility. But by using it as a server island, you can cache the actual static page. That's going to be in the edge, you know, the edge bucket or whatever provider, however they happen to implement it. It's in some bucket somewhere on the edge. When you go to the site, that goes immediately, right? That is immediately to the user as quick as possible. The page itself is like mostly static HTML. You know, obviously you can still use client islands and all that stuff, and you still get the same benefits of Astro. But the actual dynamic parts can load in later. So they load in, you know, after the page loads, essentially.
I mean, what you're describing is easier. It's easier if I just show the demo for people.
Yes.
Because this is the main product here, this luxury island getaway. The sidebar is obviously some static navigation. And then you have recommended for you, comments and stuff. And if we sit on this page and we refresh, what you're going to see is this comes in right away, and the other stuff comes in as it's ready. It has nice.
Yeah. So and they come in at different times too. If you scroll up, like the different parts that come in are
this comes much
green
quicker.
Part.
The
green part, which says just 7 rooms left. So it's basically, you know, it's checking the database to see how many of these things are sold. That's happening pretty quick. And then the recommendations, I'm trying to think, you know, maybe, you know, that's based on some like user data, like users recommend certain things and you use that. That's why that comes in late. And then you have comments at the bottom, which obviously comments can change all the time. So all those things come in at different times.
And this is an interesting one, because this same breakdown of identifying what's dynamic versus static is very similar to, and I guess why you guys call it server islands, the exercise that you did when you introduced islands to people. Instead of saying dynamic versus static, you said interactive versus non-interactive. That was the point. And when you went to an e-commerce site and you said interactive versus non-interactive, it was there was a lot of the same things. For example, like the cart is interactive, the buy button is interactive, but this is a new level, because you wouldn't say that. I mean, okay, fine, the comments are interactive too, but like you wouldn't say that the recommended products are interactive per se, but they are dynamic. And this is, I'm not gonna lie, this has been the biggest thing for me looking at it. I told you earlier that I hadn't dealt with many things where LCP wasn't like the primary, you know, wasn't behind dynamic stuff. And it occurred to me that maybe the definition of what a website versus an app is should shift because of this. And I know you're like, oh, what is this just a feature? But it actually made me think about what I assumed, because we always talk about websites versus apps in terms of interactivity, but dynamicism is actually probably arguably more important. It's something I'm still kind of playing with a bit, but like
that makes sense. Yeah.
Because like I could take something like what am I?
Slack or something.
Okay, look at this page. Now this is I mean, obviously I could list this, but and cache it to a certain degree. Like we don't need by the second updates, but like this list always changes, right? Arguably, people are always posting new stories to HackerNews, right? And even if I go here, people are there might be a link to a story, but people are always posting new comments to HackerNews. It's an interesting thing where, like, maybe this doesn't update enough that you get away with static stuff for a lot of things, because like it's mostly additive. Things don't edit. So there's an argument there, but it is an interesting exercise when you start thinking about how much of the app here is stuff that changes enough that you would be fetching it, after the fact, versus
it's about the main content, I think.
Right. Yeah,
because I mean, you could put this entire list inside of a server island if you wanted to, and like have the shell in the edge, but like who why would you do that, right? It's
right,
there's
exactly.
no point
Because what is the shell in this? It's
it's
nav
that
bar.
start, yeah,
right.
Which
and
I mean, whatever.
Right, which is fine. Obviously, right solution to the right problem. But it started me thinking about like the nature. In the same way, islands had me rethinking the fundamental nature of apps and sites. Like when I first, in that case, it was first discovering Marco. But like this difference here in terms of dynamic versus static definitely got me thinking about this again. Just because. Well, frankly, PPR didn't get me thinking about this because PPR apparently didn't have any trade-offs. We'll see in the article that there are trade-offs to PPR as we read a bit more and learn more about these technologies. But I didn't think about it. When I saw server islands, I kind of got the trade-off right away. But then I was like, it's 100% worth it where you want it, like completely worth it. And that is kind of why, kind of broadly, this is causing me to think very differently about the nature of things. It's almost like, people have been talking about, server components, and you have server and use client, right? And then PPR was implemented by kind of using a hack around Suspense. But like, it's not a hack, but it makes sense. But like, there's like it's almost like static is an outer layer. There's like static layer, server layer, interactive layer. There's like 1, 2, 3. It'd be funny if there's like instead of the baseline thinking being server, it's almost like you gotta like wrap it again, right? Like, it's funny. It was really hard for people to move to RSCs because everything was client interactive components, and then you're like, no, there's actually a layer on the outside. People kept on trying to jam it on the inside, but you're like, no, the layer is on the outside. And in the sense, the static or pre-rendered layer is on the outside of the server layer. So it's like going outwards again.
No, I like that. I like that framing of it, of apps versus sites that way. I had not thought about that myself.
Yeah, it's just it was funny that even the silly, like, for me, I use this as my site demo. Like, it's not interactive really, but a social site or something that's based heavily on dynamic content, even if there isn't very many interactive points, is of a different category than a fixed shop. Like, the thing is, I'm talking about like eBay or auction sites where they're like constantly putting stuff up, might be different in place. Most Shopify sites, most like online stores, you have a fixed catalog. You have, 498 products, each with 7 variants or whatever. And it's kind of set in stone. Like, you might add a new product, like a couple products every month or something, but it's not like every minute someone could be adding something. It's a completely different this completely, I don't know, for me, changes my look on
this demo. There's a couple of things that were a little surprising to me. The price is not an island. I would think that's something I want to be able to change pretty quickly. But if you have your cache headers are only for like an hour, then who cares? Like, you're not making dramatic price changes. And then the Shabby card and the avatar I think are not as well. But that's just, I think you would do it that way.
Right. Yeah. I mean, my understanding was that this was just kind of a port of this next demo. So you guys kind of kept the same stuff where they had the cart and then the product. Yeah. I mean, I do like that you added your own flavor to it. I actually
that wasn't me, that was other people on the team, but
yes, this is what I did yesterday. I went to Next and I just copied this app and converted it to Solid Start.
Okay. Like the source?
Yeah, like I literally took the JSX components and converted them into Solid.
Yeah.
I even left the use clients in, even though I'm not using islands or anything. I just built it as a normal SSR app, and I'll talk about that a bit later. I don't want to distract too much from the Astro stuff, but I actually appreciated that the Astro team, you guys went and made it like a similar enough to compare, but actually like uniquely skinned and slightly different demo. Anyway, let's. No, this
ours. So I didn't fork theirs at all. I mean, the Astro components are very different, so you build it in a pretty different way.
Yeah, I mean, I love doing stuff like that sometimes with Next for Solid's case, because it lets me test how similar Solid Start is to Next and how similar React is to Solid. And honestly, 80% of the changes. Actually, I'm gonna ask the chat. What do you like? I managed to convert the app in 2 hours. It's not like perfect, but can you guys guess what 90% of the time I was doing? Like, what was the hardest part of switching from an RSC app to a Solid app? I want to see if anyone can guess that. I'll even leave it out. It's not even hardest, the most tedious part. Any guesses? I actually didn't need to restructure the code very much at all, which is funny. Use state to use signal for an app like this, that there's only like 3 use states, so it wasn't big. Ding, 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 ding. Renaming class name to class. I mean, it was fine. I think class name still works with Solid, but it was actually just going over and over. Changing async wasn't actually that hard. I just had to take their await and then just wrap it and create async. I didn't bother with cache or anything. I just went like create async, remove the await, and then it all worked. But yes, class name. Some of the things are fun was I removed CLSX. I just used class list. But yeah, it was yeah. This one hit me once. I was wondering why the menu didn't work when I shrunk it, and somehow the TypeScript missed it in one location in a class list, I guess, and it wasn't setting the right like hidden menu option. This hit me once. So I guess this was the most painful in the sense that I didn't see this one right away. But this one was just like every file. And actually the second most tedious one, although might have been actually, is that Next.js uses hash further from the root and Solid uses tilde. So anyway, I'll talk about that.
I want to ask, does Marco have anything like this?
No. There is, yeah. eBay has a lot of caching mechanisms built in, but Marco was only ever worried about dynamic rendering. Like that was its responsibility.
Okay, so you're not doing something like this at eBay.
Yeah, no. The caching is like on the outside of Marco. They stream, yes. Marco is very, very heavy in order and out of order streaming happening on the same page. They'll like in order stream stuff and have out of order parts in the in order streaming, like very heavy stream oriented. But yeah, anyway, I got a tangent away. I'm sorry, I didn't mean to hijack that on. I'll show my experiments with Solid a little bit later. Let's keep this focused on the Astro stuff, because I think it's probably important at this point. Okay, 2 ways we can go here, but now that people see the feature and they see how it works, which is I showed a moment on the blog site. It's not, where was it? It's not too hard to picture. You literally just put here it is. You put server defer on a component, and then it assumes everything outside is pre-rendered, and then you just server defer, and then just like client load or whatever, like the island directives, this just does it. And there was a few technical questions people had, like, can you put client components directly in the outside the server defer? I'm gathering you can.
Outside the server? Oh, well, yeah, you can't put them on the same component yet. I'm not sure if that's a bug yet or if that's good. I'm not really sure yet. You can't nest them. People have asked about nesting. Like, I don't think we should do that. That's, add a bunch of waterfalls. Like, why would you do that? I'm not sure. Yeah, there's some technical limitations to it.
Yeah, I guess one of the questions is, can you project? Yeah, like I guess this answers my question. By project, I mean avatar is server dynamic. This is still static content being passed in between the children, right? So yes, you can.
Right. Yes.
Can,
Yeah. That's the fallback slot. So that's what's going to be, pre-rendered or whatever. That's what's going to be statically generated. Yeah.
Can the fallback slot have another server defer in it?
I don't think so.
Okay, because I agree with you that general nesting makes no sense. I think the fallback slot, someone could try to make an argument for it. It's probably not necessary. I'm not trying to nerd snipe you here. I just like,
yeah, there's like what can you do versus what should we let you do? Like, there's bugs, but like even like using a client component for a server island, I don't think makes sense, because in Astro, like use Astro for async things. So presumably in a server island, you're fetching the users, whatever, like you're fetching data.
Right.
You can't easily do that with a client component. I mean, you can do it with a client component. You can't do it on the server with like a framework component, right? Like you can't really do async stuff within a rack component in Astro very well.
Yeah, I mean, it's funny. I'm getting bug reports now of people trying to do exactly that, and I'm like, why are you guys doing this? But
we probably need to like make some decision on these things and start adding good error messages and stuff. But
I'm not gonna lie, it was one of the reasons that initially when I made the Astro adapter, I didn't have it support async, because I was like, they should just be fetching the stuff in Astro and passing it in as props into us, But I understand when you get to larger things that like you larger islands, it's just, I don't know. The way I used Astro is very Astro focused, very like. But my question was more of that: if you don't put any server defer on, your page is static, right? Which means that that static page can still have client islands in it, right? Like, that was what I was getting at. Like,
and you could put client islands inside of like that avatar. Could very well have some client stuff in there, right? Like maybe avatar is not the best well, it could be like part of a menu or something. Like you could definitely very likely want to use client stuff inside of a server island.
Right, which as I said makes it really interesting when you approach a demo like this one, because in some cases some cases most of it might just be a client island at that point inside the dynamic stuff sometimes.
There's not a good example of where you would do that here. Like the only client parts here is the book now button, which updates the cart. So those two things are client components, but they're not server components. So
in any case, it was definitely, I liked seeing this, because this is definitely an example where you can kind of see that benefit of just having the majority of the content kind of in front of you. Now, when I was the interesting part about this, and I think the part that gets people a little bit, and before we talk specifically about performance, I want to talk about how you came to the approach. I was kind of tempted to Excalidraw this a little bit. I might as well while we do it, but the interesting thing is, for this approach is that I've got I don't know what color. Let's make it green. Maybe green. I'm gonna put a CDN here, and then I'm going to put. I'm trying to think of like good colors. Well, no, okay, we'll keep that green. Sorry, and then what else do we want? We want let's make server blue. Let's go blue.
Okay.
I'm just gonna call this
server. Our origin. Okay.
Yeah. Let's do origin for now. Yeah, and then because we're gonna do a few drawings here, and then I'm gonna call this one over here where we're gonna call this one the this is going to be the client or the browser. I don't know. Which should we call it?
Client seems fun.
Okay. And then I'm going to also add another red one here for now. It's not super important. I might need this later. I'm just going to put like database. I just want to put the DB here somewhere. Just it's going to come in the conversation if we actually talk about PPR and other stuff, because then there's also going to be one more box that we don't need probably right now, which is this brown one. And this brown one is going to be called Edge. I think I have all the players.
Okay.
I think. Sorry, this one should be like that.
The Edge and the CDN are kind of the same thing.
Yeah.
But Edge is a programmable CDN, right?
Right. Yeah. Right. Exactly. So I'm trying to think of. I'm going to probably use some combination of these multiple times here. Let's just post some more over here so we can use them again. But essentially, if we're talking about yeah, these two sit right next to each other. I'm trying to think of. I'm going to start with Astros, even though Astros came later, because it's a simpler model in a sense. Because right now, client does request. Let's give it white.
Mm-hmm.
So you hit a website, right? Hit a URL.
Mm-hmm.
And it goes, okay, I need to serve this page.
Mm-hmm.
And it makes a request to the CDN. CDN responds back to the client with this information.
Mm-hmm.
And then
HTML.
You get the HTML. And then it's also, while this is happening, it's going to get other assets like, so yeah, let me
CSS.
Yeah, HTML. I'm hoping I can move this still. Yeah, HTML, right? So yeah, it's going to get other assets like CSS, JS, whatever. Okay, and at the so what the way that server islands, let's go server islands works is, if I'm correct, at the exact same time that this is kind of being processing.
Mm-hmm.
Oh, sorry, wrong drawing.
Not the exact same time, because, well,
I mean, it's inline JavaScript scripts, so it's pretty close to the same time.
Yeah.
It's going to request the dynamic stuff, and then as the dynamic stuff finishes,
which we're working on a way to make this faster too, but go ahead.
It's going to keep on doing this, but there's probably going to be some kind of, while this is happening, some kind of thing like this. So I mean, this is really rough here, but if I was to just like go here, it'd be like, and put like time here, it'd be like, let me pick a different color. It's funny, I'm like using all the colors, so this is not as easy, but I'm just, for here, I'm going to go 1, maybe red. Yeah, there we go. Stands out. First step, 1, and then what do I want to do here? I'm just trying to think of how I want to show time. 2. And then this here happens. Let's pretend that this here and this here both happen at time 3.
Okay.
Right.
And 4 is the database, I guess.
Yeah. 4 is the database. We'll just make that whole handshake 4 for it's short. Let's assume 2. I mean, I could argue that this is short as well, but and then
right.
And then 5 kind of right. This is kind of the server islands approach. Right. Now I'm going to grab this. And I'm going to, oh God, I'm so bad at this. There we go. We're going to pull this one up beside it.
Which one is this?
Let's do
Is PPR?
this.
Is this yours?
Yeah, let's do PPR.
Okay.
PPR. So similar, client goes to edge,
Mm-hmm.
and I'm actually going to put the CDN here, just enough, because we're going to, in the same way the database is really short,
Mm-hmm.
we're going to assume that this is very short.
Mm-hmm. And then
Kind of like this, right? So
yeah, I guess so.
So it's like, yeah, I mean, these aren't exact science measures. Like this is
going to the origin at the same time.
Yeah, which
as it's returning the HTML.
Right. So this is why the timing is critical, because I'm gonna just say that this is almost the same, but we're gonna give it a time too, just because. But two will take care of both directions here for this one. So we're going to say that this is like the whole handshake is 2, not just. So then 1, 2, and at the same time here, it's also going to here, which I should do as white. And I'm going to move it down a bit because the edge has closed my gap here. The edge could be further from the origin. So then we're going to make this one 2.
Mm-hmm.
And then again, this and this, which we're going to call, I'll put the numbers on it in a minute, because then obviously origin has to go back here. Yeah, so I'm going to move this. This 2's on this side, actually. And then this goes out to here.
Second time.
Yeah, and the other thing that I'm probably missing here is there are that second JSCS thing that we kind of skipped over here. I think actually they often go straight to the CDN on those. Interestingly, they don't need the proxy. Really? I guess it depends. I guess probably not.
I don't know. I think it depends on the implementation. I would expect the edge to be able to catch everything, but I don't know.
Yeah, I mean, it depends. Like the thing that we're not showing is that there's like routing that's happening in front of, like, when I say edge, I mean the edge worker, like the executing JavaScript code, rather than the routing, right? Right.
But if I deploy an edge worker to Netlify, it lets me intercept everything, right? I can intercept the HTML requests. Okay.
Yeah, you can. Yeah, I mean, it's hard. Yeah, I'm not.
They might have something special going on to not do that, but yeah, I get your point.
Yeah. Okay. So, anyways, let's skip the numbers around. So 1, 2, and 2. This comes back. So time 3, we're actually doing this, and at 3, we're actually down here doing this because we said that was close enough. And then 4 is here because this is not close necessarily. And then 5. So what's interesting about this is, and again, this is not a science on length, is in both cases, theoretically, they both finish in 5, right?
Yeah.
But there's a slight difference here in that. Yeah, so this wasn't meant to be 1. This one coming here diagonal. Yeah, this diagonal is just confusing things. I feel like the CSS JS stuff here should just be. It's actually. Yeah, it's around here. It should be, which means. Oh, interesting. Technically speaking, the CSS JS stuff is at time 4, okay? Because it doesn't happen until. Yeah, that's interesting. It's just I didn't actually think about that.
That's interesting.
Yeah.
Yeah, CSS And JavaScript is delayed slightly because it's got it.
Yeah. I mean, to be fair, this is super short, so like I'm being a little bit unfair for this, but like what we're actually, and then it comes back everything at 5. So roughly speaking, both of these models have everything coming back at the same time. The biggest difference is if you go to the CDN directly and return back to the CDN directly, you skip a hop through the edge. Now,
yes.
How does PPR written the way I've written here? How does this differ from out of order streaming where you're not using PPR? Anyone in chat want to guess?
How does it differ?
Yeah.
I think I know how it differs.
Yeah. CDN. Okay, see the other way around. The CDN sits in front of. Yeah. Okay, CDN sits in front of the edge. Okay.
Around.
Okay.
Oh, really? Okay. I think he knows. Yeah.
Yeah. Well, which is why the resources coming back would hit the CDN directly. Like when I was talking about this line, why I was talking about it hitting the CDN directly. The interesting thing is the CDN. I'm going to keep it like this, I think. And Matt, you can correct me if I'm wrong, but like, even if the CDN catches first, which is what we want, that's fine. But when you have to actually stitch the stream together, I don't think you get the opportunity of the CDN catching first. Do you know what I mean? Like you have to go, okay, I'm going past the CDN. I'm going to the worker that's actually going to stitch the stream together, which is why I think this is right.
Yeah, I'm trying to read what he wrote. It doesn't go straight to the CDN for the HTML. It can't be. Flow is browser, CDN, edge worker. Yes. Wait, back to the CDN? That's for the static, for like the CSS.
Oh, okay, interesting. He's saying that it's like, okay. So like the CDN hop actually exists in front of like the whole thing all the time. Like all these arrows that I have pointing directly to the edge or directly to the origin. I mean, I'm not doing any directly to the origin yet. Or I guess I did them here. All of these hop through the CDN, I think he's saying technically.
Right. Yeah, because the CDN acts as a router for everything.
Right.
Yeah. Yeah. When you say CDN, you're really talking about, going, maybe bucket is a better word. It's like you're getting the static, what's in the CDN bucket.
Yeah, exactly. For the point of what I was trying to get at. But yeah, and actually, let me move this here. The difference between out of order streaming and PPR, like at the edge, out of order streaming at the edge, not at the origin, out of order stream at the origin, and PPR on this drawing is basically none, except for if you were getting that content, like what Matt was saying, where it's CDN edge back to CDN kind of scenario. Like if that's funny, it's like CDN edge, CDN. Like, you know what I mean? Because you have to, I think you're grabbing the static stuff to stitch it into the response that you then send back out again. Anyway.
Right.
But yeah, the only difference is where you render, right? It's do you render here or do you render here? Essentially for the dynamic stuff. For this, so when I made my demo, I was playing fair. Like the static shell, I'm not fetching it from the database, I'm assuming that I have cached data instead of cached HTML. And then I'm using the framework to render it from the edge in my out of order streaming example. So I'm like, I've cached data. The framework's going to render it every single time. I'll worry about that comparison later. But regardless of the pieces I'm missing on the routing or the CDN's role, you can definitely see, like, if anything, we get more hops when we're going back and forth between the edge. And with server islands, you can see that this is just like direct, like HTML to, and I didn't put the arrow back from the CDN here. Like, this is coming back at, let me change the white. This is coming back at 4. So like the CSS is coming back sooner. The JavaScript is coming back sooner. Like there is benefits of just, like, obviously the timing between these hops is pretty quick, generally speaking, but there is benefits here of like getting everything sooner when you do this direct communication from the client. You can definitely see it.
Yeah, no JavaScript, just straight up C++, highly optimized CDN code. Yes.
Yeah, which is interesting, Matt. I'm going to show something in a little bit to that degree, but
that's spice.
There is spice here, because I actually didn't realize this until I built the demo, because I hadn't really looked into PPR enough. But let's continue with the Astro article, because okay, before we go back to the article and talk the performance numbers you guys got, what inspired this approach? Like, I know you were key on implementing it. Was this one of your brainchilds? You were talking with people. How did this come about, that you guys decided to take the, like, instead of doing like streaming from the edge or that, but just to do the direct CDN origin approach?
I mean, it wasn't for performance reasons, right? I mean, really, like, Matt Kane gets credit here for, he came up with the approach. Matt Kane used to work for Netlify, worked on Gatsby, so it was his idea. I think he was definitely motivated by what you're talking about like going straight from the CDN back to the browser. I mean, for us, I think ultimately it was just, less code, to simplicity was the reason, right? We can do it all from the client. It will work on any host. I mean, I really believe that, like, that time between the edge CDN to your browser is so short that, like, the overhead of not getting a head start on the origin request is, like, not that big of a deal in reality. So it's just a trade-off between, slower starting, running the island code of fetching the islands, to, like, having a faster, largest contentful page, because your main content is the main thing. That's why the user goes to, like, this page, is they want to see pictures of the vacation destination and that sort of thing.
Right, exactly. And you guys did a test. This was kind of funny, because I was trying to reproduce the test. I wanted to do it on stream with everyone, so we could actually, like, look through the timelines and doing that. But then I was checking my history here, and it looked like Malte made a few tweaks to make the demo even faster, which involved changing the timeout delays. Now, I understand he made other tweaks to inline the tailwind and stuff, but it means that the demos aren't actually the same speed anymore. So it's harder for me to show what I wanted to show on this. I guess I could pull down their old version. I ended up copying their new version. So it's fine. I guess Twitter had a field day on this one. This is one of those things, like I've done this before myself on a demo, where you're tweaking something else and this isn't the important part, but because you changed the most obvious thing in the demo, maybe because you think it looks better or it's, like, more realistic, people
yeah, I mean, I didn't like, yeah, I hated all the, I didn't love all that stuff. I thought, like, the point was not to say that, like, server islands are faster than PPR in every scenario. They certainly are not. And it was just to like, you can do this in a much simpler fashion and get the benefit of, you know, being available on every host without needing to do all that stuff. So PPR is fast. Like their demo is fast, right? Like you bring it up, it's fast. So
for sure. Partial pre-rendering for everyone. I'm trying to find it actually. There was an article, or pretty sure, Matt wrote actually. And I don't know if you saw this one. This was showing how to do this from an edge worker, so to speak. The only difference with this approach was wasn't combining on the client. It was using, I think, HTML rewriter to combine it on the server, which means that I think, if I understand what's happening here,
it's blocking on
the it'd be blocking on the edge function, I think. In its sense, you want the stitching to happen on the client regardless. It's easy to have the stitching happen on the edge function. It's easy if you're doing what you guys are doing to have it happen on the client, because essentially you just have, like, if you're in one location and you're like, get me the missing parts, that's not too hard to do. You can do it from the edge. You can do it on the client. Proxying it through is a little bit more complicated than people are going to do without a framework, is what I'm getting at. Like, out of order streaming that we do in Solid is technically starting the process on the edge and finishing in the client. And same with PPR. We stitch in the client, but we thread everything together in the edge worker. It's like proxying it through. It's a little bit more complicated. The easiest version of way of doing this is actually wherever you're going to put it together, that be the place where you originate the request, so to speak. So in that sense, I remember seeing this, that I was like, in a sense, the server islands approach is although I guess the tricky, I mean, this doesn't block the initial shell, I don't think. Like, you get the initial shell right away, but I don't know how this.
It's doing out of order. I think if you scroll up, I think that the scripts in that right there, it's pending scripts, it looks like.
Oh yeah, it is doing it. Okay. Yeah. So this, exactly. And this is, okay. So I was mistaken here then. So this is the proxier. You need this HTML rewriter essentially to do this. Okay.
Yeah, and we thought about doing it that way. I mean, some people have asked for it, but just based on the results, like this is not the core of Astro. I don't think. Like it's a I won't say niche feature, but it's a feature for like a very specific type of site that can benefit from, that is both dynamic and static at the same time. So we wanted to do something that was like maintainable, and that the script that we have is like very, very small, and all it does is replace the HTML, right? So it's like, it's a very nice little enhancement to Astro without, it doesn't have to be a fundamental thing.
Yeah, no, exactly. And there's an interesting benefit here about caching, right? Which was that, like, the static page you get from the CDN is always the same. Like it is interesting though, like technically, even with PPR, the static part that we're kind of pushing through is also always the same, but the browser can cache the response of the Astro version, I guess, is the biggest difference.
One thing about this approach is that you're blocking the HTML request by streaming it in the HTML, and depending on the browser, that can affect paint time, right? Because the browser will say, hey, there's still stuff coming in. I'm gonna wait a little while before I paint. So that's a downside you have to think about with this approach and with PPR.
Yeah,
I did.
No,
go
yeah,
ahead.
go. No, go ahead.
Well, I was gonna say I worked on an out-of-door streaming project like 5 years ago that was based on H2 push. Do you remember H2 push?
Yeah.
Yeah. So for those who don't know, H2 push was this way that when HTTP2 came out, you could set what I think they called them in their frame. There's something called a push frame. Basically, you could say because HTTP2 is multiplex, so you can have multiple streams happening at the same time. So you can start pushing data on a stream while the HTML is coming. Basically, the browser can receive data and HTML at the same time. So what that out of order streaming did was it started the stream on the server, used HTTP push to push it, and then the client it did a fetch.
Right.
So it's kind of a combination of what PPR is doing and what we're doing now, where you do get the head start on the server, but the kind of, I guess, more similar to how we're doing it as far as you're just fetching the result.
Yeah, it is interesting with HTTP2 being multiplexing in terms of the fact that it can share the same connection for stuff that's like immediately happening as it's loading, which is something that I actually experimented with a bunch this week. I actually made an example where I took Solid's hydration scripts and pulled them out of the HTML document and then put them in the head of the document to try and grab them. So it would start initiating right to a stream on the server while it was rendering, and then the fetch would grab from that already getting written to readable stream because I was like trying to figure out how to make the document smaller. I don't know if people have been following my work here, but serialization size is kind of like a big pain. And when you do islands, you can save a lot of serialization because you don't need the double data, because you don't need to hydrate those parts. But so far, anyone who's added persistent states with client-side routing has kind of had to add the data back in. So I was like trying to figure out, like, the one that really got me was Quick. Quick doesn't even hydrate practically. Like you can load the page and not do anything, and it doesn't need to run any JavaScript code. And it was getting nailed as hard on serialization as everyone else was, right? Like the second I went from MPA to client-side router, all the data serialization came back. And I was like, it just tanked it. And I was like, well, can I improve the score by like loading you want it there soon, like almost immediately, but can I improve the score by not making it part of the like HTML being sent in? I didn't see drastic improvements. I mean, I like doing like death tests on my HackerNews demo, and I did manage to go from a 72 to a 78, which is, something. So I'm still kind of undecided on the impact that, plus I didn't do it complicated enough. I just streamed in the serialization stuff. But the JavaScript, unlike HTML, it's not going to like start executing the like parts of the JavaScript while it hasn't loaded the whole file. It's like HTML is amazing in that like it starts parsing and executing parts of the HTML. I don't think like JavaScript. I'm not 100%, but I'm almost fairly certain if you have like a large JavaScript file that's getting like streamed to you, it doesn't start running
slowly,
running
it.
But
Start running it. It probably does start parsing it though.
So yeah. But probably doesn't like start running it. So from that perspective, I'd actually need a more complicated solution than what I was working on.
The other issue with the HTML streaming approach of out of order is that if you wind up with a lot of like little tiny scripts, that actually in the older browsers, at least, that actually is, can be somewhat of a problem, is because those browsers are not that great at like executing, a bunch of little scripts. So that's something to watch out for.
Yeah, I think. Yeah, there's definitely impact that. It's just interesting thing for me, at least, is because eBay's been using this approach for over a decade. Like I'm not like I generally have like been like it's probably okay.
They do it that way. Is that how they do it? They pin scripts. Okay.
Yeah. So like but like it was definitely interesting because we have this spectrum now of these solutions where so like partial pre-rendering, like the big thing is like this here is basically just out of order streaming with a static source, right? I was trying to ask people what the difference was, and they were saying it was because of Vercel's special infrastructure that made this communication here way faster, that there was a benefit to it over just doing out of order streaming. This one, it's very clear to see that this is a different thing, right? It has very different characteristics. This actually looks a lot like when we built single page apps, right? Like JAMStack,
of course,
right? Yeah. You went to the CDN, you got maybe your app shell, maybe it was a mostly blank page. I can't remember. JAMStack was statically rendered. So yeah, you go get your app shell, and then there would be holes, and then the client would start fetching against an API server, and then it'd come back in. It looked basically identical to this, like if you're just looking at the topological thing, right?
Yeah, I mean a little bit, but you weren't really doing islands back then.
No, exactly. Yeah. The difference is the communication was in JavaScript, whereas server islands, the communication's in HTML. You need almost zero JavaScript to pull off server islands. That's the beauty of it, is that this whole communication is happening even from here to here before you've rendered your JavaScript framework. Whereas in the old JAMStack approach, usually what would happen, like not on all the frameworks and stuff, but usually what would happen is in the middle between these, it'd be like, okay, let's start fetching JavaScript. There's that second pass for the JavaScript. There's that, let's hydrate. There's like,
Does PPR block on the framework loading? It doesn't, does it? I don't think.
Right.
It just, just starts appending stuff, right?
Right. Yeah. From the server, we can keep on. PPR doesn't. No. Yeah, exactly. Like we can just keep on rendering stuff out, and we might not like hydrate it till later. But infrastructure makes a difference, right? AWS CDN node, Cloudflare Edge, is how Vercel works. Netlify, they're on the same edge reason, and this actually makes, I think my gut is this is why they have the fancy PPR kind of mechanism for Vercel, because it's almost like it's making up for this. Like, can I show you guys something? I make HackerNews demos all day long, right? So I obviously have a HPS Hacker Solid. Let's see, what was it? HackerNews Edge Netlify. Yeah, right. And there's like time to first byte, 28 milliseconds. My LCP here, it's because of the size, they gave me 2 LCPs, but my original LCP was 0.92, I guess, which was this top section. And then I finished out at 0.15. Okay. Now, I didn't notice this until this morning. I kid you not, which is weird for me because I'm usually like doing, all this profiling stuff and looking at the timelines. But then I went in and, what was it? Just a second, I might have to go to GitHub to look at this up again. Solid.js, solid. And HackerNews.
So is this the new demo you're just
no,
showing?
This is my demo that I made on stream that everyone has seen me make over and over again in different frameworks. This is the classic one. Okay, so I have my Vercel one, and then I have Vercel open like a new tab. Okay.
You if you stand up and go get a glass of water, you trip over a HackerNews demo. You just have them laying around everywhere.
Yeah. And what was really interesting to me, interesting. See, now it's not going to do it. Damn it. That's okay. Apparently I have no point that I was going to make. This is interesting. Okay. That's unfortunate. That's not what okay. Well, never mind. Just a second. Sorry. It was, I was running this all this morning and I was having this terrible luck. Maybe it was just a time of day. Let me see if I can find this. I just want to make sure that my network has disabled cache, because these numbers don't make, those numbers don't make sense to me unless, console. That's okay. Well, never mind what I was going to show. I actually I did this like all this morning on my other computer, and I was like, what's going on here? And yeah, it's not showing what I had seen before, which is interesting. I think. Okay, I'm not going to worry too much about this then. I was having a hard time with my HackerNews demos in general, showing consistent time to first byte. The LCP obviously to these things are kind of similar, but I was sitting there and I was like, yeah, this could be interesting because I actually don't know how everything's going to look then, because I thought I actually saw a lag in all my Vercel Edge demos, but apparently that was not the case. So I'm not worried about that right now. Yeah, I kid you not. It was doing this like I was just like I was in disbelief. I was like, this can't be right, and I was like sitting there jamming it, and I was like those numbers make no sense. They said the time to first byte was 3 milliseconds. There's no way that someone. Do I have a service worker? Like there's no way that 3 milliseconds. Yeah, I wonder if. Oh man, that's so
3
weird.
milliseconds for which part?
Time to first byte against the edge.
Yeah.
Like something is not right here. I almost want to get to not that one. Oh well.
Do you live like right by the CDN? Like, is it?
it's like on the corner. No,
walk away.
No,
yeah.
no. Something is not right.
By the way, the chat is incredible today. I like Matt's just giving away every secret about how CDNs work. Like I think I've learned more about how they're built.
Yeah, no, definitely. This is super interesting stuff. Why can't I? Yeah, sorry. I should just leave one of these pages open so I can look at the demos again, because I did this. I already looked this up before. There's just something not quite working, which is bugging me, because this doesn't. There's no way that timing works like that. Okay, give me a second. I want to go back here and take a look, because the one thing was that Cloudflare is actually really fast. I noticed that right from the very beginning. This is not okay. Okay, this seems like more normal numbers.
What do you got?
Yeah, this seems like more normal numbers.
Yeah.
Okay. Yeah.
100 milliseconds. Yeah.
Yeah, and time about 40 milliseconds to.
Oh, first byte.
Yeah. So okay, I guess these are actually pretty comparable. Where I am here. What was the other one? Solid. HackerNews Edge. Yeah, this is the thing that I was noticing is on average, Cloudflare and Netlify Edge with my demos were faster. I don't know why. It was just you could kind of see LCP 129 and 130 and 460, 400. That one's not bad. 140, 340, 4. And again, it could be just my location where I'm sitting here, right?
Mm-hmm.
That I was getting better results on both Cloudflare and Netlify Edge pretty regularly this morning, and I was just like, how much am I weighing this stuff like in the wrong way? Like, because I'm not gonna lie, the first thing I did when I saw the server islands demo was to do what I always do, right? I went on both demos. I looked at them both, and I was like, I was like, here and then I went to performance, and then I went to settings, and I went network, throttle, slow 3G, and I did the thing, right? And you can even visually see this. It takes longer to load, right? Obviously because it's slower network. And then, yeah, where is it? Let me try it again.
The islands or...
Yeah, the images are brutal, but it wasn't the images I was talking about. You see like the recommended trip delay kind of coming in, and then I went to next, and I did the same thing, right? And I refreshed, and obviously it takes a while for the page to come in, but if you notice, the stories were there right away. And the reason there'll be extra latency on the round trips, right? The same problem we had with spas, right? If your main content that's off the screen, or like it's this like little thing, comes in slower, no one really cares that much. But the biggest trade-off that I saw was like I immediately went to the full length because in my head I was thinking LCP is prime, right? In terms of like dynamic content. And it was one of those things where I was like, wow, like this is actually considerable, right? I think I told you in the chat, I was looking at it and I was like, the Astro stuff always came in faster, no matter how much I slowed down the network in these simulations. But in terms of like the initial load, but afterwards, the difference was up to like 2x, almost 3x multiplier difference because of the waterfall, right?
Yeah.
And Fred's response, which was a good one, he was like, yeah, we should have tools that if people try and use server dynamic on what would be their LCP content, they're using it wrong, essentially. Like that's not the point of this technology. It's for showing that initial content. And then we
can actually I will say we can make that a little bit faster because currently they're all post requests, and they're post requests because technically you could pass props through server islands, and those props could be very large. So we can't do a GET request because the URL, there's a limit to how long URLs can be. However, I think in practice, most server islands are not going to have like all that many props. In which case, we can actually use a GET request. Which, if we do a GET request, now we can add a preload, so the browser will start fetching it much earlier. But yes, it's going to be slower because we're not doing the head start.
Right,
So
exactly.
If you look at the if you do like the film strip view, you can see that as well. You can see that the PPR finishes first.
But the interesting thing was when I went here to the performance tab in the slow 3G, and again, unfortunately, we can't really compare it because of they're using different delays now. I think it's all in now. You could see that interesting. This stuff, streaming is never really good in these tools, but you see the page loading and it starts loading stuff before it's done the HTML, and then the JavaScript comes in, and then is this even a good run? It's hard to tell from this. This is not even a particularly good run. What do we got? First paint about 2.27 seconds, and then LCP comes in at about 5.7, right? If I take the Astro demo and do the same exercise, right? And you're going to see a very different looking timeline. Let me get there. Here, probably 10 seconds. Okay. You're going to see the page be much shorter, or not much, but a bit shorter here. And the stuff, and then the round trip stuff coming back. So, but the interesting part for me that was always that, okay, LCP, so first paint is here. And maybe I should run this a couple times. What's first paint? Yeah. Okay. Yeah. I'm going to run this one more time. This is not what I saw earlier. Let me run it one more time. Sometimes like these things are.
Remember the delays. The delays are not the same anymore too. So you were comparing the
right exactly
finish because it's not delayed as much.
Yeah. Exactly. The delays not being the same might impact this now. Yeah, because what I saw previously was that the first paint was basically at the exact same time, around 2:30 or something. But then the LCP, you can still see it here. LCP for Astro is 4.99, and the LCP for next is 5.73, which means
so
it's over.
Why is that?
Why is that exactly?
Why is that?
Because the page roughly still kind of comes in, the main core part of the page, if you look at the timeline, still comes in like in Next's case, they're done everything by 2.5. But I imagine this is what we want to estimate. It's pretty close to maybe 2.1. 2.1
how
right
close?
there.
Sorry, go ahead.
I was just say, like, this is like pretty close to, like, when it finishes getting the shell of the page is about 2.1, probably about 2, maybe a little bit more, maybe 2.2. And if you go to the Astro version, you finish your request, 2.2. So the HTML of the initial chunk and this thing come roughly maybe 100 milliseconds off each other at most. But LCP for the Astro version is always over like half a second faster. Which is significant, obviously.
That's, to me, it's those blocking scripts. It's the HTML blocking. It's not the overhead of running the edge, I don't think. Right. It is the streaming. Right.
Yeah. And the,
I mean, for years browsers told us don't block HTML, right? Like, that's why they added defer to script tags, and they added async to script tags, and type module is defer, by default. So, like, they had all these things saying don't block HTML. So I think we're getting the benefit of doing it that way.
Yeah. And to be fair, I don't actually know what the cause is. Right? Like, this is
I don't either. I was going to ask, like, what's the difference between their LCP and like when it's all the way done? Is it pretty much the same?
Yes. I can't see that from this chart though, right? Because, like, let me take a quick look here. Let's see if we can see it, because it's hard to tell, because, like, there's no, I'm trying to think. We can look at the animation frame timing, but I think, like, the difference between this, maybe about 2 seconds still. It's like there's like still a delay. Like, it registers the load event way back here. I don't know. See, like, but the load event triggers on different things. Like, here, it's doing the load event at the time the LCP comes in. So it's like, it's hard to say.
It's doing the load event at the time the LCP comes in? Is that what you said? That makes sense to me, actually. For this one, I'm sorry.
For Astro.
Well, no, that makes sense too, because the load event is when the initial HTML finishes. Right?
Well, I guess it's when everything finishes. The JavaScript is actually what's pushing off the load event for the next one.
Exactly.
Which is interesting, as I said, because, like, this has been kind of the challenge to look at this, because, like, I don't know when it renders in. You can visibly see when you just sit on the page here and refresh. If I just do this, you can kind of see that when it comes in, it's like there. It's actually the images taking the longest under this slow network condition. Whereas, like, if you look at this kind of model and you do the refresh, you can see the recommended trips kind of take a bit longer. There's a bit of a delay, but I mean, it doesn't. Because this was below the fold, like, you couldn't even tell, right? And you have the original longer delays too, right? So, like, it's kind of a coin toss. The interesting thing for me was, it's hard. It's very hard to tell the difference. I actually had the this is the streaming version that I put together, right? And this is not using islands, not using PPR, not using fully isomorphic JavaScript. Like this, there's no savings on this in any case, right? So I mean, the streaming takes about the same length as Next, right? Where it's like there, and same idea, where around the 2 second mark, the page should be finished. But if you look at here, the LCP is reporting at 7 seconds for some reason, right? But my gut is if we look at this, it'll all show up at the same time. Yeah. So it's like it's hard to tell from the metrics of like these kind of tools, right? Like what's another tool we can look at? PageSpeed Insights is another fun one. We can take this one. PageSpeed Insights. We can take this one.
These are not the same anymore, though. Like I think.
Yeah. But one thing you have to your benefit, or not to your benefit, to like they only care about LCP on PageSpeed Insights, like generally speaking. Them not being the same is a little bit unfortunate. I will admit. Yeah, because one of the I'm just gonna for fun just do this.
I mean, assuming we're right that like the load event is what delays the LCP, then you're kind of in a situation where the lower the delays, the better your LCP is going to be. But if your delays are not that high anyways, like are you getting like a huge benefit from it in the first place?
Yeah. This is the fun part about running these all the time, because you never know what kind of results you're going to get. I'm again seeing different results than I saw when I ran repeatedly earlier. So it's like, but yeah, I mean, the Astro results are exactly what I saw before, which I was seeing larger LCPs actually on all of the demos that I was putting out here when I was running this.
Is this
earlier.
mobile?
Yeah, this is mobile.
What's the device they use? Does it say?
It should be like was it? It's this. They should say it's the same one that they always use.
Oh, there it is. Emulated
Moto G with slow 4G throttling, right?
Yeah. Yeah. What's the LCP? 1.2?
Yeah, 1.2.
Yeah,
that's pretty good.
That's pretty good. Yeah.
Yeah. We just run it one more time, because I was definitely not getting. I was getting like I was getting much larger LCPs this morning when I was testing. It was interesting though. This is a different one too. Actually, while I'm at it, let's just. I want to do HTTPS : see if. There you have it. That's did even better. That's very impressive on the timeline.
Yeah. The variation makes it kind of hard to compare a lot of times.
Yeah, but this is good though, because the biggest difference actually is I'm seeing improved scores on the PPR that I did not see when I was testing earlier. Because if you look at the because this is just testing the LCP, like mostly testing the LCP content. It cares about the initial load, right?
Yeah.
And what do we got here? It's so funny because like the variations change every time. Oh, apparently there's unused JavaScript on this one, apparently. But like just to kind of get an idea, the total size of network payload was 166 kilobyte. Root document took 20 milliseconds to come back, which is impressive. Large contentful paint at 900 milliseconds, where the PPR version took 80 milliseconds to come back and 207 kilobytes. Interesting side note is that the JavaScript execution time on this is 0.1 seconds and 0.9 seconds of main thread work.
Which one is it? Is that PPR or is that us? That's us.
That's
okay.
you. Yeah.
Yeah,
And then the PPR version had half a second of JavaScript execution and a second of main thread work.
Yeah, that's because I mean actually the ours has React as well. It's using React for the client component. So
because and actually that's funny. My solid version has 0.2 execution time, and this is fully hydrated, not using islands or RSCs or something, and main thread work is 0.8.
Yeah, that's pretty high actually. I would expect the ours to be lower. Wait, this is yours. I'm sorry.
Yeah. But this is actually lower than the Astro React demo. For main thread work, which is surprising. More JavaScript execution, which I'm not surprised. But yeah, the largest contentful paint takes longer in this example. So this is a good root, but it's interesting. Yeah, the root document took 60 milliseconds on the Netlify version, and it took 150 milliseconds on the Vercel version of the same app. So out of all the demos, the Astro got the root of the document in 20 milliseconds. The Netlify streaming got it in 60 seconds. The Vercel PPR got it in 80 seconds. And the Vercel streaming got it in 150 milliseconds. Sorry, milliseconds, all of them. Yeah, so it's interesting. I'm still curious on the delay, right? Because this is the interesting question starts becoming like, what causes, like when I was doing this test earlier, I was seeing 1.8 or 1.9 consistently on largest contentful paint out of PPR. But when I'm looking here, we've run it twice now and we're getting 1.3. So higher blocking time, 80 milliseconds versus, I guess Astro's one is, I think, pretty low. Say it's 0. There you go. Versus 20 in the streaming one. Oh, and 0 on a different run of the streaming one. So I don't know, pretty open for being inconclusive. I do wonder if this LCP thing is repeatable, or if there's this I was looking for proof that the PPR aspect, how much it impacted large contentful paint. This suggests that it does, is basically because I was like, what's the difference between PPR and out of order streaming? And I think it's so funny though, because when you look at the timelines, they don't look very different. In fact, it looks like if I look at the snapshot here, it looks like like by the time it renders the first screen, like or is those just placeholders? It almost looks like the reviews, or no, I guess that's just the product description. Yeah, that's just the product description. So yeah, by the time it renders the first thing, it's hard to tell. Basically, because this LCP stuff is off the screen, you can't even tell anyways, which I think is kind of the point.
Yeah, it's like, what is the most impactful content? Like, what is your user going to the site for? Like, that's what you need your LCP to be about.
Yeah, you need to run it like 10 times. Yeah, I know. Yeah. It was the question obviously is I guess just stepping back from the pure performance thing, it's clear just looking at even the timeline here, like the server islands version, it's like there's no white at the beginning, right? If you look at the PPR version, you look at my two streaming versions, there's white at the beginning. So right off the bat, in terms of accomplishing the goal, this smashes it. Like,
well, I think that part makes me think that would be the edge overhead, I would think, right?
Yeah.
Because otherwise, the browser should start painting the HTML right away.
Yeah. I think the interesting thing is the edge overhead wasn't the only thing impacting these JavaScript frameworks. As we could see here, that in my demo here, the streaming one, the LCP is large for some reason, even though the content arrives in like the root arrives in 60 milliseconds. Like the difference, obviously Astro gets it like right away, 20 milliseconds. But the streaming demos, yeah, so 80 for them, 150. You know what I mean? Like the paint's still delayed. So I think there's more probably to kind of investigate on those sides. But yeah, I mean, I think there's a comment about the effort taken to implement this stuff, and I think it is definitely interesting that in terms of Astro, you just go server defer and literally and once you put that on there, you can just deploy your Astro site anywhere, and it pretty much is going to work the same way, right?
Mm-hmm. Yeah, I mean, you want to have somewhere that has a good CDN and whatnot, but yes.
Right. Yeah, definitely. Which is interesting. Yeah, definitely. The CDN thing does actually make a difference here in terms of that. The very fast getting that 20 millisecond return on the server island thing. Whereas, yeah, I guess it's the streaming demo was also fairly easy for me to do because obviously Solid supported streaming, so I literally can just go write my app one way and just deploy it somewhere. I can't leverage PPR anywhere except for Cell. I need to come up with. I guess what I'm wondering. I'm still trying to decide with all of this if PPR matters, which is basically
versus like edge rendering.
Basically, yeah. When you have the full spectrum, it feels like if you care about initial load, the approach that Astro Islands is doing is almost a no-brainer. Like I'm ready to stamp that and be like new JAMStack. Like it's just like
wow.
No, but I mean it's like JAMStack again. It's just like it's this kind of thing. You don't care even if those little bits take 3 times longer when you're browsing from a Moto 4 or whatever over in Dubai or whatever. Like it doesn't matter actually that much. The core content is what matters here, even if it takes like 3 times longer than the whole thing. And if you're, yeah, I mean, the simplicity just makes this really compelling. And then on the other hand, if you really care about, like, sure, you could leverage PPR if you have the ability to, but if you really care about like your application, like your main content isn't static, it's dynamic, then like I wonder, like there's a lot of constraints that come with running PPR. I know, I'm curious to see. As I said, these results were not the same results I got this morning, so I have to kind of think about, my conclusions here a bit more. But
they're all really fast, and it just comes down to
I'm like complaining about it and whining it, and meanwhile you're looking at them and they all scored 100.
Yeah. I mean, I think their conclusion, like circling back to what you were saying before, was that like the edge failed, and so it's really, if you have that perspective, then edge is for like frameworks to write code. It's not for like applications to run code. You know what I mean? Yeah. So that's. I mean, I don't know if that's like. Yeah, go ahead.
Yeah, I don't know if that's the conclusion I get to from here though, because the edge's ability to be dynamic and speed up, like. Yeah, I'm not like, if you are to believe that conclusion, you have 2 options. Essentially, you have to come up with something much more complicated like they have with PPR, or you just kind of go screw it. But kind of like Astro Islands is a bit like, who cares, right?
Yeah,
and yeah, I obviously on the Astro Islands side, Server Islands, I can say like clearly I get that, but I don't know if the other conclusion. Like if my only goal is to do what Astro's doing, then I could come to that conclusion. but then I should realize that Astro's version just does it better, so I should just do it. You know what I mean? If I'm not trying to have that goal, I don't think I'm not sure that the PPR advantage actually makes sense. That's what I'm kind of sitting around with.
Okay.
Right. That's the thing. It was like when I was crying. Yeah. I mean, I'm gonna have to like kind of sift through this more, as I said, because it's interesting because like obviously like when I was doing my streaming demo, I wasn't trying to do any other types of optimizations. I literally just was like, I'm not even going to try to do islands or any, you know, kind of thing. I literally just was like, all the JavaScript, go.
Mm-hmm.
You know, so yeah, it's interesting. Anyways, let's pull back out here. I don't need. Let's talk a little bit more generally. I believe it's a good time to ask Matthew any questions you might have for him before he heads out for the day.
Yeah, where do I look? I look in the comments.
Yeah, let's look in the comments. See. Yeah.
Okay. What do we got? Signals and Astro win. I don't know. I mean, I have thought about it, you know. It's like if Astro was ever to venture into client-side rendering, then very likely, but yeah, not soon, I would say.
Yeah, it's one of those interesting things because like, I know why Dev's asking though, because he's not thinking. I don't think he's thinking client-side. He's thinking about like, yeah, I imagine he's thinking about some pretty crazy stuff.
Yeah, streaming ruins those types of ideas on the server.
Yeah, exactly. Yeah, so having the signals like talking to the front end. Yeah, so I mean, that whole category is interesting because like, do you guys? I guess you kind of leave it open, but like, are there like blessed WebSocket type approaches or whatnot? Like,
no. There is one cool signal thing we do have with Preact. So if you render Preact component, you know, using their signals implementation, the value is serialized with the island and then like rehydrated. So you can actually have shared signals between Preact islands using their signal implementation. So that's pretty cool because, you know, cross island communication is something that's like, you know, a little manual in Astro. So that gives you a very smooth way to do it. So you could see a world where we made that generic to all frameworks, but it's very hard. You know, obviously, like that's not native to React and stuff like that. So I don't know how or if we would ever do that kind of thing. But I do think that Preact thing is pretty cool because it solves that pretty nicely for them.
So when you said like they serialize the signal as a prop, essentially, if I'm understanding, so that like future updates,
yeah, I can't remember exactly how it works, but there's I might be wrong here, but this is how I imagine it working. For each signal, there's like an ID for that signal, right?
Right. Yeah.
And when you render the Preact component, it saves that signal ID like on a data attribute. Right. And then when it goes to rehydrate, it's like, all right, this is signal 1. I'm going to hydrate the value. And then when another island hydrates signal 1, Preact knows that this is the same signal and it just gives them the same signal. You know what I mean? Does that make sense? They actually have the same instance of the signal. So if they start changing the value, it's going to, you know, reflect over on the other side.
Interesting. Okay. Yeah. It must be, the serialization signal. Cause like in my head, I was like, I was trying to figure out what that did differently than just like literally using a signal in 2 places, like, you know, like the singleton pattern, like the way you guys like use NanoStorage, right? You just like import a file from 2 locations, put a signal in it, it will work.
Yeah. You don't have to write it in a global sort of way like that.
Right. Interesting. Okay. That's cool. Yeah. I hadn't really thought about that. And another cool one is the quick Astro integration.
Mhm.
I understand it's probably not using Astro to do a whole lot, but it
Right.
keeps Quick's ability to wake up, like
Yeah.
hydrate on signals. So like if you write one, it'll like wake up part of the page, like that
Yeah.
depends on it. But I think that's
Yeah.
more.
Yeah. It is pretty cool. Like, yeah, it kind of it does its own thing. Like, it basically just uses Astro as a shell, but it's
Yeah,
pretty cool.
yeah. Okay. Anyway, let's see, what do we got here? Can server islands take advantage of speculation rules? You could prefetch all islands, perhaps.
That's interesting. Yeah, so I don't. I mean, I know what speculation rules are. Like, speculation rules are a way to, like, you put like a JSON thing in the script, and the browser parses that and will start fetching stuff. So it's kind of like a preload, I
Right.
think.
Yeah.
I would probably just use preload. You do
Yeah.
preload as fetch. I don't know if speculation rules would be any better
Yeah.
in that regard. I'm not sure.
Yeah. Yeah. I think. Yeah. I imagine like at the. I mean, I'm not sure. Person asking the question might know better, but you'd think like if you're going to the CDN and you're just grabbing the islands, as soon as you get the beginning of that HTML, that's like the soonest you can, basically start
Yeah.
grabbing the next stuff. Because the other
Yeah.
one I was thinking about was the 103 headers, like the hints. But
Hmm.
again, probably doesn't matter much because that's great for like streaming, right? Like so, like you could send the hints out before like content, but you're returning the static stuff like immediately anyway. So like,
Yeah.
yeah,
Yeah. The browser's really interesting how it like does that. Like, it has something called what's it called? A preload scanner or something. Like, before the parser actually starts going, it does
yeah,
kind of like a very generic parse of it to start to figure out what it can start fetching. That's how it's able to fetch like CSS and stuff quicker. But it can actually go further than that. Like, it can, inside of a fetch call, if you have like a static string, which server islands do, it can in I don't know if it does, but it can in theory start fetching those things too. If it sees something that looks like a URL, it might start fetching it.
yeah.
Someone asked a pretty good question here. Sorry, I'm taking over your stream.
Go for it. This is the best part.
Will server island support streaming JSON from the server instead of initiating the fetch in the client? So this is like where there is like a little bit of overlap between a server island and a client component, because you can do a lot of things you do with server islands by just doing a client component. That's how everybody did it before. If they wanted to have like an SSG app, it's the JAMStack, right? You can do the JAMStack thing. So there's a lot of overlap there, but the difference is that the server islands have this much script, whereas a client component has to fetch. You have to go back to the CDN to get the framework JavaScript and then run it and stuff. So yeah, I don't think you would do that. I guess I would say it's really for streaming HTML, not streaming HTML, but for island HTML.
Interesting. Sorry, there's a comment here about the speculation rules. Hydrates before you navigate. Speculation will render all JS.
Oh,
So
I
like,
think yeah. Go ahead.
yeah, I mean, I don't know. I was just gonna ask, like, before, like, how does it?
I think what he's saying is that, so you're on page one, and you can have, the same way you can have prefetch rules to prefetch the next page. You could know that if the user navigates to this next page, they're going to need this particular island, and so it could start prefetching that before it actually does the page. But I'm not
Oh,
sure. Like, yeah,
oh,
go
is
ahead.
it like a manifest of not just the current
Yes,
page, but like all the
yes.
pages? Okay, okay.
Yeah, I get what. I don't know if that's the intent of it, but I guess it can be used that way. Although if you just do a prefetch, it's going to, just like if you use prefetch, does it start? It's not going to start executing the scripts and stuff. But if we did have preload links, I think even prefetch would aid this a little bit.
Yeah. Oh, I see here. Benton was actually asking as well. I think he was wondering if you would ever like do Astro support doing stuff from. Do you mean like PPR basically, like move initiating the fetch on the server or on the edge? Like I'm just reading the rest of the, like.
Yeah. Fetch all assets from the page and do that basically. Yeah. Yes, I don't know if we would ever try to do the PPR way. I don't think the benefit outweighs the maintenance.
Okay. Yeah. Yeah. I think like there's a very clear win on the approach that's taken here. That kind of, as I said, it's. I wonder. I do want, like it. I guess we'll have to see how the front end frameworks develop, like the remixes and that develop. But like, if your app, yeah, it's really in that middle zone, because for a lot of tools, out of order streaming will be fine. I think without both out of order streaming and the server islands approach don't incur the need for this extra infrastructure. So like, you have to basically be in this spot right in the middle where you want this characteristic to invite the rest of this complexity. Basically, like you want to have something that is almost as fast as server islands for that initial chunk, but also like cares enough about the stuff that happens afterwards. Like,
you want something where your main content and your secondary content are like almost just as important, I guess.
Yeah. So it's interesting. Yeah, I'm not sure. It is like, I am seeing the value. I keep on running in the background the Lighthouse page speed stuff, and it's been relatively consistent. The consistent thing is that the PPR is getting better LCPs than my my demo I made using no PPR, and that consistently Netlify's edge is outperforming Vercel's edge. That's about the only two pieces of consistent, except for obviously PPR for Vercel is faster. So it's like, and obviously Astro is faster than them all. So those are the things that are consistent. Things aren't actually varying all that much. So yeah, I don't know. As I said, this has definitely broadened the way that I've been thinking about stuff, which is really valuable. And something that I probably have to ponder on a lot more. Anyways, Matthew, I think we're good on the questions for now. Is there anything else you want to say before you head off?
No, I mean, keep in mind, if anybody's watching this and wants to try server islands, please do. It is experimental. Probably don't use it in production yet, unless it's something that's not super important. There are bugs and whatnot, so just be careful. But otherwise, check it out. And we got a new release coming up next week that you should check out as well.
Awesome. Yeah, very exciting stuff. New release next week for server islands, or just Astro in general?
There'll be some server island improvements likely. I added that it's going to start encrypt. I don't know if we don't know for sure if we're going to have this in, but I've been thinking about encrypting the props. People might pass secrets through server islands, not realizing that it actually goes in the client, and you don't want that stuff exposed. So yeah, I'm pretty sure PPR does encryption as well, so we might be doing that. But yeah, we have other features coming, like for content collections. It automatically generates a schema for like your JSON. You ever use? I don't know if you know, but in VS Code, you can in a JSON file you can pass a schema for that JSON file, so you get like autocomplete and stuff like that. So we auto generate one of those for you. That's coming up next week.
That sounds cool. Yeah, I haven't actually checked that out. All right. Well, we'll let Matthew go now, and the stream's going to continue. I want to show a few other of my experiments that I did this week. I did some more performance tests, and there's going to be a little bit more Astro in there too, because I used the Astro Solid Island implementation as my baseline, to know what performance looks like. And then, that's been a lot of my work recently, actually, is I use Astro as like my vanilla baseline for a lot of the SSR stuff, even the like Cock I did at React Summit, because it is really trying to bridge this gap. Astro is like my norm, or like what we can accomplish, but I want to accomplish other stuff, and I need to see if it's possible to accomplish the other stuff and keep Astro's characteristics. That's kind of like how I've been approaching things. So anyways, it's been great to have you again. We'll probably have you on again, another 6 months or so. So I'm very excited to see what else you've cooked up by that time. So very awesome.
All right. Yep. Thanks for having me. Thanks, everybody. Yeah. Great chat.
Yeah. That was pretty awesome, man. I've been definitely, I don't know if you can tell, like this whole thing has definitely been shaking my perspective here a bit, because it starts with understanding how for like you know that left to right diagram, like the spectrum talk about websites, like going from like content sites all the way over to like Figma or whatever. Like I always knew that Astro made sense for the whole left side, and honestly right into the middle into e-commerce. But I feel like I understand better now, like the difference between, say, an auction site and a fixed storefront. Like characteristically, when you think in terms of not just interactivity, but in dynamic versus static. So like this shifts this rotates the space, because I'm always like looking at this as kind of like multi-dimensional space, and Astro is kind of coming in at this angle that now makes me want to rotate things a little bit. And I think that this has huge implications on RSCs and my thinking about what the unified approach or model is. Because obviously things like islands, things like RSCs, like partial hydration, make a ton of sense when you want to reduce the JavaScript, and being able to communicate in HTML or markup. I'm going to put RSCs in this bucket. Do alleviate this JavaScript concern, but on the same side, like I'm also not sure that RSCs did anything to change the results of like the benchmarking or this demo. Like PPR is possible not because of RSCs, but because of Suspense. Essentially, it's just streaming, right? So like yeah, it's kind of interesting, just like when you try and put this all back together and what the implications are. Because if my goal now was to basically build any site where the LCP was pre-renderable, or mostly pre-renderable, I'd just pick up Astro. I don't really see much point of doing any of the other stuff. I mean, I've always been a big fan of, promoting and pushing people to use Astro when they ask, I like, what type of site are you building? But it's like, it's also the area that I never really contend with. I'm on the dynamic side, like apps and stuff. But it's just like, it's making me question what the gap, like filling the gap, looks like. Because like right now, that middle zone, which I think is basically only RSCs really live in, looks like it looks challenging, because it's basically like both sides have ganged up on it and made the middle look like the worst possible option. You know what I mean? Like it's easy when everything's flowing one direction, right? Like when you're saying like, we're going to make our app frameworks better for websites. But when the website side comes back and goes like, pushes back in a real way. And I know some people consider HTMX that, but yeah, I don't know. Maybe this is just the HTMX argument again. It's just like it makes a considerable impact on like how awkward the compromises in that middle space look. Like even the whole like mutation models and stuff, like if the left if the ability of these tools that cater primary to the left side have actually expanded significantly past their initial bounds, like if you view it as a spectrum and like they sit in different places, if the left side is actually pushed over far enough to the right side, it makes the right side look silly a little bit. And that's just the nature of these things. Say server client cannot be automated with the same type of server islands, or can you? I mean, you can definitely automate server islands. Server islands are way easier because okay. And in this, React has the right kind of thinking. Perhaps I was thinking that the boundaries might I said that like statics on the outside, then server, and then interactive. Like there's the 3 levels, like static, dynamic, interactive. 1, 2, 3. But what's the difference between? Well, actually, maybe not. No, this is fair. I was thinking that this would be easy because, in a sense, mechanically, all you have to do is identify that this data is available. Because, like, it doesn't need to, like, in React, you use suspense, right? But you don't need to stop the first suspense boundary, like the topmost suspense boundary, and say everything outside of that is static. You can render that suspense boundary if the data is available. And then it's the inner suspense boundary. So, like, from that perspective, if you authored your app in such a way that you had suspense boundaries or like places where you care about async placeholders, and then you had async data loading, and then depending on what data was available, cacheable, that could split dynamic from static for you automatically in theory. But I think the problem is, and maybe this is why PPR is taking a while from Next side, I'm not 100% sure, but I think the problem is mutation kind of story, right? Like, how my biggest gripe with server components is mutation. Like, it's very awkward how everything gets pulled back in again. Like you need these server caches, otherwise we're re-rendering, refetching, re-pulling everything. Where client side is hyper granular, you don't need to have that problem. You need to think about your app in terms of rate of change. And I don't know if compiler can detect that because it's not enough to say stuff's available. I mean, maybe that's where the decision happens when you decide what's cacheable or what's available from a data perspective. That can drive the UI to automate where the split is. But like, I still think understanding the characteristics of rate of change is something that the developer would do. I mean, we can get into some kind of like some kind of like AI or something that can like determine like, okay, this changes often, let's pre-render it. This changes less often, and do a cost analysis. I mean, another interesting thought about it is handle this the ISR ISG way, right? But where essentially, if something's not available, render it and start like just caching these partials, like hyper caching, essentially. Like every little piece is cacheable, and then like you stitch them together. It's not just one level of PPR, but it's like it's just a like caching stitching solution. I'm positive the guys over at Vercel were thinking that way with how extensive their cache API was, that they were thinking like, but the challenge about that obviously is like, how do you know which suspense boundaries you need to fetch dynamically or statically at the time, right? Like, there's both the edge where you're like making the request and figuring out like what I want to ask for, and then there's the server who has or doesn't have the data. So like the combinatorics here would probably get prohibitive. I don't know. It's interesting. Yeah, I mean, obviously that, but I mean, people are looking, I think, for some kind of unified story here. Like, they want to be able to choose one tool, right? Because I do have concerns on the other side. I think a lot of people are going to go out now and be like, okay, I can use Astro to build my apps, and um, kind of like, if it's like the situation where you have like, the benefit from Astro, and then you just like throw a single page app on a page, like, sure, you can do that, but like, then you're not actually leveraging the good parts of app building. So like, I sit on one side, that the left side, like where, the more, content static stuff lives, always, as it gets further to the right, it always embarrasses the right side. But the kind of flip of that is, um if, generally speaking, if there was one who was going to do a weak impression of the other, the right side's always more capable of doing it. um okay, so if you define data cacheability, have suspense and dependency graph, you could automate server islands. Yeah, probably. Yeah, I think that's a fair answer. I just, server islands, PPR, this whole category is a caching strategy. The first question is, you have to decide, are you communicating in JS or HTML? In the same way that we're kind of like full circle here, when I'm talking, I'm like, this is just a spa again, except you're communicating in HTML. It makes a difference, but I just, it's tricky, right? Because I mean, we already know the trickiness of communicating in HTML when it comes to like client-side routing, right? And persistent state and state tearing. I'm probably going to need to spend, obviously, more time thinking into this, but I am definitely impressed with what Astro has put together with Server Islands. Feels like this is the final piece of that. Maybe not the final, but this is the completing piece of that story. MPA basis, view transition APIs, cacheable shells. All of those technologies have gaps from an app's perspective. I would say ones that are very nasty to deal with. But from a site perspective, this is the best version of this that we've had to date by far. Like, it's just, you can if your mindset is like, I have a multi-page app, I'm an MPA, so you're not really sharing state, and you know that most of your content is statically rendered, right? And we're talking about a ton of sites like this. You can basically effortlessly make a page that, or make a site that you can navigate around with client-side routing, essentially, like not go back, not do the full thing. So it feels smooth, incredibly fast, and handle, the interactive bits for you. It's like a no-brainer, right? I think, like when you look at a screen like this and you see, sorry, where was it? Like, you see the LCP here, like essentially the only thing non the LCP is out here. You start like thinking about how expensive all this stuff is in order to accomplish something that seems like fairly simple. Like, the biggest problem with this Astro demo is that it uses React. Like, I think like, how big is the Astro demo? Let me share my screen again. We saw that there was overhead, and even Matthew was like, this seems a little bit high, right? I think it is high. Like, I think if we go to the network and we look at the JavaScript and we load the page, actually, let's do this from incognito. so we're not getting like my extension code stuff coming in. If I load the page here, 42. How much JavaScript do we have? 46.1 kilobytes of JavaScript. So 42 kilobytes of React and 4 kilobytes of like app code, maybe, or like 3. Yeah, like from this, my estimate is that if you used Svelte or Solid, this page would be 10 kilobytes of JavaScript. Now, obviously, we're not dying over 46 kilobytes of JavaScript, but what I'm getting at is when you look at something like RSCs, and if this is what you're trying to produce, like it's never going to cover the gap difference. Like how big do you think this partial pre-rendering app is from Vercel or Next? 107 kilobytes. Like obviously we're just squiggling over little numbers, but what I'm getting at is like, if this is your site, you're never going to do anything that was ever justify, like even the Astro here, like let's go streaming storefront. This isn't even using. Okay, yeah, there we go. Yeah, so this isn't even using islands or like any partial hydration technique. It's 34 kilobytes for the solid example. Yeah, so that definitely convinces me that it's about a 10 kilobyte site. Obviously, we don't need to squiggle over little details. What I'm pointing at is like, if this was your website, you're never going to close the gap that the offset of using Next is worth it. Like that's the takeaway I'm getting from this. Like, this is why I seem probably pretty pro all this. Is like, if this is what I was building, like I don't know who builds storefronts in large masses with fixed catalog, like Shopify. Why am I using React framework? Like I'm sorry, Remix, but like this is just like the obvious choice. Like you're never going to capture the gap. Like LCP static. I don't care if the dynamic stuff comes later. Don't need any of the JavaScript. Like it just doesn't. None of it actually makes any sense that we have, these bigger, larger tools. Yeah. It's speculation. Rules supported most browsers. Like usually when new spec stuff comes out, you'll find framework authors drag a bit because of support. Because like we've all been burned before. If usually, I mean, usually, I'm not. Usually, someone tries it first, and then others will kind of go onto it. And my experience, at least on the spec stuff, is about every couple years I go back and try a bunch of stuff that was first said about 5 years ago, and then usually I'm disappointed, and then eventually it comes in. So like it's quite possible I'm just not actually like, yeah, I need to read up on this one obviously a lot more. I mean, yeah, Remix could use to move to Preact, so that would help a bit. But what, Preact with RSCs? No, I mean it should just be fresh with all of Astro's features. Yeah, it's Chrome only right now. It's useless. Yeah, I mean, this is the challenge with this stuff. You always. The funny thing is, the second it gets in all the other browsers, it will be a different story, and then it'll be like, "Yay!" Right? It's a two-way street. You need to have people champion it for to get through there. I get it. React makes a lot of sense for our sales department. I don't know what that means. I could see it making a lot of sense to the HR department. It's just, you know what I mean? Like when I'm looking at these solutions and what you can produce with them, it's like it might not be that RFCs are wrong or the approaches or the stuff they're doing. It's just that Astro is doing a very good job of showing that the gap in implementation is just like unacceptable. There's reasons for those trade-offs. Don't get me wrong. I am big on what React's been doing in terms of like how do I put it? Like I keep on saying that this is like the new JAMStack, you know, the Astro server islands. It makes sense for all these things and it's incredible. But like on the same stand, I never used JAMStack. So like I thought it was underpowered. So like I'm not saying that what React is trying to do is not good. I'm saying that we're in a place where the gap between doing something efficiently on the simple end and doing the, you know, right solution with all the things considered and the fully overpowered solution is big enough that it's embarrassing. Or it's starting to be, which is good. This is how the giants fall. But this stuff always bugs me on both sides, right? Because on one hand, the stuff that's like happening like on the React side is very, very valuable and it's being missed. People just don't understand the limitations of, say, what's being done here with Astro. But on the other hand, like, yeah, I don't know. Maybe that's just the reflection of the mess things are in. Like, it's funny because we've shifted from like, how should I put it? I remember a time where like Vue and Svelte were relevant, right? Like that was the conversation. How do we make it easy for developers to join on the web, right? And we would talk about it, and we talk about syntax, and you know all that kind of stuff. And even Svelte carried that torch for quite a bit longer when they, you know, like the whole meme with like let count versus use state and all this, and no arrays on dependencies and all this stuff. But like, I find myself now only talking about signals, resumability, and island/RCs, which is unfortunate because it's why I don't talk about Svelte or Vue very much anymore. So like, yeah, there's something here. It's just not quite where it needs to be yet. It's so funny. We are so much far ahead. I don't know if you guys remembered when I first started streaming about I don't know how long it was, a few years ago. I feel like now, maybe it's before, it was in one of my articles time period. I said something along the lines of like, people ask me what I think of Next.js. Maybe I didn't write this in an article. I just like wrote it somewhere else. But you know, and I said, you know, and I was like, I didn't get why everyone was patting themselves on the head. You know, basically in terms of the realm of server rendering, we're like a 2 out of 10. We have gone strides now, like huge strides. You know, I feel like we're in like a 6 or 7 out of 10 range now where we want to get to, but it's like it's still not enough. Yeah, no, exactly. Like people will ignore this whole line of thought, this whole line of thinking, the whole thing that I'm talking about, and just pick a tool and be happy with it and just use it. You know, and that's great. But yeah, I mean, the reason I talk about React so much is because React is doing relevant stuff. It's not because they're popular. Being popular is not enough. They have to be doing relevant stuff for me to take notice of it. And this small little feature is just the perfect shakeup. Like, here's the thing. Astro's combination of features and stuff like these that we're talking about here has gone to a point now where I feel like general devs, backend devs, even might be like, oh, Astro doesn't seem that bad. It's like, I think they are hitting a sweet spot. The weakest part of Astro, arguably, is the client isomorphic part of the story. And that's because they don't own it. And I mean, they've talked about taking it on, but then they're in a whole other mess. I don't think Astro necessarily should make their own client framework, but it's also the wall of where their ceiling ultimately will be. It probably doesn't matter, but it's like, yeah, I don't know. I think Astro is very compelling. Incredibly relevant to enterprise that frustrated React. Yeah, sure. Yeah, exactly. Like, and just want an app in front of their REST API. Why are people frustrated with React? People are frustrated with React because React is trying to actually improve things. I think this is the challenge, and people just don't even realize it yet. I guess the thing is, once you're somewhat successful, it doesn't matter. You can just keep on going on those laurels, so to speak, of adoption. But like, you need to be able to. You need to be like, if you don't change with the times, you're just like, obviously enterprise is going to love you, but you're not relevant. I mean, it's a two-edged sword. If you have customers, they will hate you for it. If you don't have customers, people will view you as unstable or immature. So at a certain point, you just got to dig in and say, like, this is where I draw the line. It's just like, I don't know. We were talking about the Stack Overflow survey. Like, things have been kind of like a mess a little bit, right? Like, I don't know. We'll talk more of this as the stream continues on. But what I actually, before I finish up this point, I want to show a comparison that I was doing this week. I had this kind of funny idea where I was like, what if we took, solid, what was it called? Solid HN experiment dot netlify dot app. I came up with this kind of crazy idea. I was looking at the page source of the doc size of stuff, and I was looking at the server islands, and I was trying to figure out why stuff was painting faster in Astro than next. And I was like, maybe the HTML document matters, right? So what I actually ended up doing was if I take this and take what was it, solid start HN Netlify app. Okay, these are both HackerNews demos that are deployed to Netlify proper, not Edge, just this functions. And what I did, was okay. This one's 4.7 kilobytes. How big is this one? I think we need to find a sizable page to do this comparison. This one's 5.8 kilobytes. What I did was I removed all the Laravel, all the serialization code out of the HTML, and then put it in a, let's look at the network here. Let's go all, I put it in something called, where is it here? Sorry, this tab. Put in something called hydrate JS. And then basically the hydration script just writes into a JavaScript file. And then in the head of the document, I put in a I just put in an endpoint, like a get. And what I did was I made it so that while I was rendering, I was warming up essentially. I was like writing to a stream that would be grabbed from the get. So basically it's starting the request right away, but instead of streaming it on the same request, I'm streaming it out on the same connection, but not as part of the HTML document to see if this would improve performance, right? On a large, one of these larger pages. Because if I find a larger page, and I think I have an example here, like this one, let's do this. These giant pages. 401 kilobytes for the HTML payload. Sorry, I'm missing a slash. Versus being able to, what's this one? 200, right? Basically, the double data problem is killing us. So can I basically half the data in the HTML document? Is there any benefit of doing that? So I don't know. Honestly, again, kind of inconclusive. I did my test. I actually read it on WebSpeed, and I put Astro, which doesn't do the double hydration. So the difference between these is ships with the HTML, doesn't ship with the HTML, but comes in through the fetch request, doesn't need to do it at all. Right? I could have used solid start islands, I guess, for this as well. But I basically did like one of these like timelines. And the Astro one doesn't stream either, which is unfortunate. But the streaming time was almost identical. But the one that came in the HTML, do you see that it painted later? I don't know if this is a consistent thing, but it is interesting to me that like it did start streaming earlier, and I don't know if that's just a coincidence, but it actually, yeah, I'm starting to think that the way we stream might be problematic, to say the least. Yeah, I mean, the way I did this is it's a hack. I didn't do it here, but my idea was that I would render some kind of ID, one use ID into the page that would like look up. I just didn't do it. Like the idea is that you server rendering the page so you can dynamically come up with the right endpoint. So you basically make a dynamic endpoint hit for every single page and then basically destroy the thing once it connects to it once. I'm sure there's tons of security holes. I wasn't worried about that. I just wanted to know what was possible. This one would also be slower to hydrate if you think about it, because I haven't actually processed each Cerevel command separately. I'm not. Yeah, I mean, I'm temporarily stateful, right? I'm leveraging fetch, right? I'm hoping that, I don't know the exact details, but with HTTP2 multiplexing, it should be possible to do both requests on the same connection, which means that I don't necessarily need like a fully stateful server. I only need it to be short-lived stateful. And yeah, I mean, I wasn't even like, if it's serverless, I'm not even worried about like cleaning up after itself. Like if something misses, like if there's an error, like it's a very short-lived cache essentially is the idea. But yeah, did I? Okay. Yeah, so let's just run these all again then. Because it looks like I lost them and they're on different URLs right now. That's why we're getting different results. They should all be on the same URL. Let's run these again. I ran them the other day. So normal solid start. I don't know if this is an indicative run. My experiment and Astro solid. No, this was inspired by server islands. This was looking at what the cost of data serialization. When you use islands, you don't need to send all the data if it's only used on the non-hydratable parts. It was just bugging me that basically once you add client-side routing, it's not the islands, because like Quick is another example. Once you add client-side routing, the data serialization comes back in. Astro doesn't, but Astro is also cheating and will break very easily if you try and do anything with it in this scenario. Well, I mean, Astro is better in perceived speed because I don't care about the fact that it didn't stream in. It was done all the content at 8.1. It's unfortunate that it doesn't stream. I wasn't worried about the streaming. I was worried about the finish here, which was the key. Like basically when it painted is what I'm most concerned with. Not this, but when it paints the main content. Obviously, Astro is faster because it doesn't like Astro is basically done. Like it's not. I should put it. It's not when it's like Astro comes in around 6, right? It's not when it like finishes I care about. It's like when I first see the full content. Yeah, like around 6, 7.5, 8 point something. That's the one that I actually care about. Maybe I should change. Yeah. Streaming has an impact. I think it's actually better to stream in general. You'll load other stuff faster. It gives you a loading indicator. So like definitely these coming in sooner is better overall. I just meant that this technique of deferring the serialization is I wanted to see if it impacted contentful paint is essentially it. No, it didn't, but that's because we also cheated. This is why I pulled it. I was working on the Islands router, and then I'm like, this is so freaking broken. I don't understand how anyone could. I can't release this to people. And then Astro released the view transition API, and I was like, God, this is so broken. But again, this is a perception thing, or it's like like I'm building apps. I'm not building sites. If I'm building sites, then it's perfectly fine. If you stay within the lines of what Astro is intended for use case, then it's like you're not going to hit it. But like I could never release something like that for solid. Like it would just be so broken. Like it's because of our app focus, there's like a higher bar, maybe not on performance, but for expectation. It's a kind of way like, when we don't do something React does, people are like, oh, well, React does it, like we have to make sure within our category, which is app generation, that we do stuff that's sensible for apps. That's why I still say, hey, you're building like a content site, go use Astro. Use it with Solid because it's going to be, especially in that use case, like probably much better than using React. I'm usually very, like don't use Solid, better React or whatever. But like if your page is like 5 kilobytes or something, like why are you bringing in a 40 kilobyte framework that's not doing anything for you? Yeah, I mean, it's just brutal. Anyway, where I was getting here, how did we do? So yeah, long story short, even though the timelines looked really nice here. Okay, actually what? This might be this looks like it was a bad run for our experiments. And let's make sure that this has all 406 comments. It does. Okay. Yeah. So again, 90% for Astro. This is what we expected. This is the demo that I always demo with Astro. I've seen anywhere from 90 to like 94 when I was with Fred, so there's a little bit of variation. Solid getting 64. This is just like my conference talk that I showed you guys. Scores better than most front-end frameworks. Very similar to React server components, even though it's doing the full work, right? But the question is, can the experiment improve on it? And my thinking, I've seen it get in the 70s, but maybe it's just not significant enough for the complexity. But this is one of those things I'm weighing. Give this another run. I like, if this something like this would score in the 80s, like mid to high 80s, like close to getting to like this stage. Because my whole theory here is that the serialization is the cost completely. So obviously we eat that because we have to serialize on the server. It's going to make the server respond slower, right? Potentially. But okay. But if the cost is happening more on the client than on the server for serialization, then things get interesting. Because just follow me here. Maybe we don't need to solve double data as readily. Like this is a bad case. If we don't need to solve double data, then it changes things again, right? Like this is like, it's kind of like the Astro bet, but the opposite way. If you don't need to solve double data and you have basically very cheap hydration, like Solid or Quick does, I mean, Quick is the cheapest, obviously, then you now have an alternate app model that looks pretty compelling compared to RSCs. Basically, RSCs are like the ugly middle child. I conceptually think being in the middle there is where like the potential to like accomplish everything is. But like, who cares if the other models are simpler and can be made more performant in their range? This is interesting. I don't know if this is repeatable, but this is the first time I've seen 80s without partial hydration. We barely see 60s without partial hydration. This is full isomorphic SSR full page hydration, scoring 80 on the death test. Yeah, I don't know. Maybe there's something here. Usually I'm like of the mind that I want to like unite things and come up with a single model, but like my gut is if I took this approach and mixed it with Quick's resumability, we'd have basically Astro level scores in a client routed single page app. I mean, there's other problems there. I feel like if you're going to use resumability and you want people to use it, you got to do it slightly different than Quick. But like, this might be another path. I don't know. This could also be a fluke run, and I'm like speaking a bunch of nonsense. Yeah, I mean, to be fair, our friend Matt Billman actually gave me this idea. I don't know if he realized he gave me this idea. And then when I saw server islands, I wanted to try it again. So, yeah, it's interesting. I'll say that much. I see resumability being the last 10%. Is basically, which I've been saying the whole time. I don't know. This is interesting. I don't know. Maybe this suggests that it's worth further exploration, because if something like this works, then like this would be very easy to, not easy, but fairly easy to implement into any existing SSR solution. Like Solid Start could just like use it the same way you use it today, and could probably, like, this is a worst case scenario, so we would only see like small like jumps on other kind of serialization scenarios, but it does make you wonder about this. I definitely have things that I think are more pressing than resumability, but this is not that far out of our wheelhouse. It's interesting. I don't know. Main thread work. Yeah, you know what? Astro isn't cheap necessarily on main thread work when you have tons of islands to hit. I think someone was talking about this before. This test is inconclusive, but this is interesting though, because yeah, it basically splits the difference. Anyway, sorry, I've dwelled on this too long, but it is definitely interesting. This is turning out to be a really interesting stream. I feel bad for all those people not watching. This is like probably my least watched stream that I've had in the last year, but yeah. Okay. The problem I have with this idea is hard to implement with automatically scaled stateless service. Oh, okay. Yeah, and this is probably where I'm going to get caught here, because here's my question. HTTP2 multiplexing. Yes, this is what I'm getting to. I guess the problem is I can't guarantee the load balancer behavior, right? That's why this doesn't work, right? Like, just because it shares the same connection doesn't mean that it'll share the same resolved like worker or server, right? Like that's the part I'm a little sketchy on here, because like I was like thinking, I'm like, the whole key to this is I'm literally fetching back on the same connection that I made initially. But the problem is the connection only goes as far to as like where that routing happens, where they decide where to handle it. Like the domain resolution, like it gets there and goes like, okay, I'm here. They can send you somewhere else, right? Yeah, but the whole benefit of this is I'm actually rendering the JSON at the time of initial rendering. Like I'm actually using the same serialization specifically for you. Now, obviously, if I need to persist it, we can use like Netlify blob or whatever. Like there's techniques that we can use to do this, but then there's infrastructure constraint, right? Everyone these days is having it, like Vercel has it and whatever. But then you start getting into the same zone that Vercel's in, where you're like, oh, you need SKU protection for your next app or whatever. Like you start basically asking people for a bunch of infrastructure. It might, obviously, if you had a single server, it would be fine. But like, I don't. Yeah. Yeah. I mean, yeah. It's fine. It's just it would be really cool if same connection meant same machine, but I understand why it wouldn't. It's like what Matthias was talking about earlier, right? When he was like, it all goes to the CDN first, like um yeah, okay. That makes it less easy to implement. This approach would have to be proved, but I don't know. It's interesting, right? Anyway, that's enough on this topic. I'm trying to keep the stream short today, so I'm gonna move on to the next topic, which is I got a couple HackMDs waiting in the wings here. Okay, first thing, a little bit of cap up on Did I not stream last week? I did not. Yes, that's right. First, little cap up. We were. Yeah, there's another derivation document. Yes. First thing, async. After the last stream, everyone's like, oh, not everyone, but people were like, what if you did allow tearing? Blah, 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 blah. And I actually wrote a whole proposal about allowing tearing, right? I'm going to drop this one into chat. And what it would look like if we didn't top level hold. Basically, almost immediately, thanks to some people in the Discord, I realized that not top level tearing is just terrible. I get picture JSON. Yeah, JSON is definitely faster on the client side than JS, but I think it's harder to do deduping and to do like fancy resolution, like because you got to self-reference to do things like promise resolution. But yeah, terrible. Thank you for the joke. Yeah, no, it doesn't work. Someone showed me an example. I think it was Brendan, and he was like, because when I was picturing tearing, I was picturing holes in the HTML, right? Like, oh, this hasn't loaded yet, kind of like that demo I did for you guys. But he was like, what if a CSS class depends on something async? Well, if we just allow tearing, you'll have like flashes of unstyled content as async data comes in. I know that's like not the like realistic common example, but like it could literally be anything, right? That just happens to be there. You could like render part of the page and then not render the CSS for it, or a certain data binding, like you don't have the value for a select list or something. Like it would be chaos. The one benefit of doing this exploration is of making tearing work is that I did have kind of a realization that around if I don't want to use suspense was that like that if we ever want to opt out of suspense, maybe not including a fallback would be a way of doing it. In a sense, top level suspense and like no suspense essentially, and perhaps the ability to opt out of lower suspense probably should have the same behavior is what I realized. Not a huge revelation. I'm just going to say that after thinking about this all, this doesn't speak well for PPR, ironically, but I'm coming to the conclusion that, I mean, this is hard for our reusable reactive system, so to speak, but top level tearing and top level holding both suck. And the best answer is just to error, which is probably not what people want, because I was trying to make things, reflective on server and client. But the reason that, like, how React, if you don't put a suspense boundary, it holds. The thing is, that's fine for RSCs, but it would never work as a good pattern for anything that hydrates in the client. So I'm beginning to think that the goal of, having that behavior is actually the problem. It's probably like React in the client today. Like if you try and read from an unresolved async value outside of suspense, it should just probably error. There doesn't seem to be like a happy version for everyone, right? Holding sucks. No one wants that. Tearing is basically useless. So like, I think that's where this sits right now. The only downside of throwing like that is that suspense like mechanisms would have to be built into the React system. I was planning to do that anyways, but it's something you'd have to like consider at a reactivity level, not just a UI level. Yes. This is what React does in the client, but on the server, in RCs, it just holds the stream, which I thought was really convenient because it means that people who build their first React app and have no idea about Suspense just put some async stuff in and it just holds. I think holding on the client might be okay, but it's error or hold. That's basically the only options. Is loading the future try catch? Yeah, kind of. Yeah, because is loading guards can always protect you from throwing. Right, but if we synthesize top level suspense, then that would just be holding everything, right? I mean, we could, but it'd be suspense with no fallback. I mean, that could be the answer. It could be just that, essentially. But you have to think about the way you write your code. The reason this works is because they never hydrate the server component. If you write code with top level async, and then I put a suspense boundary on the server at the top level so it works, that suspense boundary has to be in the client too, otherwise it's going to error. With RCs, that suspense boundary does not have to be in the client because those components never hydrate. The problem with is loading is you basically need to hoist dependencies you should check outside of the children. Right, because the is holding has to happen at the level where the data fetching is going. That being said, with this run once suspense model, yeah, I mean, I'm okay with this because how should I put it? If you're the one introducing the async, you're kind of responsible for it to a certain degree. I guess you got to make sure that there's like some kind of suspense boundary above where it's read. That could be above you. Arguably, you could have suspense higher up the tree. If you're really not playing the suspense game at all, then yeah, I mean, do the is loading where it's read. It's not like you can read something that's created below above it, right? I'm not suggesting people use like it's the reason suspense exists. If you're gonna like try and make a bunch of show components with is loading, you should just use suspense. It's like Suspense's inversion of control, where you don't need to know that all the async stuff below yourself, is why suspense is good. You can't simulate that with is loading. Is loading is just like a wait tag in Svelte. It's just like localized. So I think this is fine. If you need to know something's loading higher up, yeah, yeah. I guess the question is, I mean, it's an interesting one, right? Because I do see the scenario you're talking about. Like I use transitions for most of those scenarios where you have like a bigger widespread change, but like it is. This is an argument for not doing run once suspense because I mean it's hard to do micro outside of transitions and is loading type things. It's hard to do like pinpoint updates that don't skeleton, right? You could say that like, well, it'll skeleton, that'll push it up the tree. But like I also kind of think you don't want to. So like if you find yourself in that position, yeah, I know what you're talking about. You're talking about a scenario where it's like doing async stuff down here, and then you have like a spinner higher up in the app. But you don't want to unmount the whole page. You just want to like, yeah, yeah. Those feel like transition type scenarios. Yeah. Yeah. I mean, or you can drill it down. I mean, but I think that's the whole point. You want to kind of like avoid hoisting and drilling. Okay. In general, though, I think that, yeah, my gut here is that erroring and then like putting in the top level suspense is probably reasonable, because yeah, I mean it's interesting. It could be holding as well. Like if you could view create root from a reactivity standpoint as like the suspense boundary, like the way I started looking at suspense, and I talked about this a while ago, is this idea of flush boundaries, like this idea of like controlling the way the effects run, and basically hierarchically sectioning them off that way. So in that sense, like create root from a reactive standpoint or some variation of it has the potential of being like a suspense boundary. So you could see the holding be built in that way. In either way, tearing seems like it feels like garbage. So like I'm done with that. Okay. Let's go to, yeah. Okay. This one I was pretty excited about. Again, this is one of those examples where you like do a stream and then like I get a crazy idea over the weekend and then I write it out. And this one makes me feel a lot more confident about the derivation story. Okay, let's talk about this for a bit. I realized that I need to attack derivations from like a more fundamental level, right? And what it came down to, it was down to the nature of change or reactivity in the first place, which is, people don't see this all the time, but there's basically two types of reactivity. There's immutable and mutable reactivity. And you're like, well, obviously immutable reactivity is still like at the point of mutation, something changing. Like it keeps its reference. Reactivity is all mutable from like a pure functional standpoint. But for me, it's about boundaries. And a signal is basically immutable. Yes, you can change the value of it, but you don't mutate it. It's like it's always a single value. There's no, like, you don't change the value inside. Whereas stores are mutable. They're nested, right? So at the very core level, when we talk about solid, we talk about create signal, to do, set to do, right? And then when you do the new one, like if you wanted to change, let's pretend you had an object inside your to do signal. If you wanted to create a new, like update it, like you would either just make a new object here, but assuming you just want to toggle done true, the correct way to do it is to clone the to do and put the to do done on it, because this is immutable. Inside this function is a mutable change. It gets the previous state, returns the next state. You don't mutate the current state. This is fundamental of signals. It's the same as React signals are. What people miss is one of the benefit of signals is that they can be nested. And that changes the property. That's the magic. That's the difference between the React compiler and Solid. React will always only be this. This is why we can build stuff like those to-do app things they do with the compiler and have perfect stuff without the compiler, perfect exact updates without memos, without compiler. It's because we have this ability to push change out in a granular manner. See, in here, conceptually, and this is not like the way to update a proxy is to mutate it. You go to do done equals true. You don't return the next state. You don't clone it. This would be very wasteful. You'd have to create a new proxy. You just mutate what's in sight. And obviously, Solid has immutable helpers for stores today. That's why we have the Path API, which I've always loved, because I liked encouraging people to think about stuff immutably. It just makes it nicer to kind of like declare. It just felt really nice. That's why I like the current store API. But from a fundamental standpoint, the produce API is the more fundamental for a store, or the mutation API. I like keeping my reads and writes separate, so I've still got them here. But generally, my proposal for stores in Solid 2.0 was this, essentially. You have immutable atoms and mutable proxies. Okay, you guys with me so far? Yeah, I mean, the whole thing was a store. Yeah, at that point, yeah. Similarly, we derive stuff, right? Immutably or mutably. I mean, we've never done this before, but the immutable way is createMemo or compute it, right? If you want to add a priority field, project to do with the priority, you shouldn't mutate this because it messes with things. You have to actually clone it when you createMemo. I'm pretty sure, I think people understand this, but like if you edited the to-do to put the priority on it, then the signal would have it on it as well. If you actually want this to be a derived value on an object, you would actually clone it, right? Above here, set to do, done true. For this example, yes, I could have done that. I was trying to show that, pretend there's other fields on here, like maybe this is the problem with this one. ID 1. There we go. Done. There we go. There we go. Fixed it. There's nothing wrong with that. I was just trying to show that if you're trying to apply a granular change to an immutable object, you clone. Right? I mean, the reason that I showed it this way is because the sets, like, obviously we can also like not do this, but it's because this function here is this function here, more or less. And the function form of the mutation should be the function form of this. So, like, do you see what I'm getting at? Like, a memo is the function form of the setter, right? There's a definite symmetry to what I'm talking about here. Now, we've never seen createProjection, but if there was a createProjection, it would start with potentially having a blank slate, like an empty object, and you applying the fields that you want updated to it, right? You could grab that from some immutable or immutable source, but essentially you would create it by mutation versus creating it by cloning. This example is actually really poor because the source of this would be, yeah, you notice how, like, this to do, I'm taking the previous to do, like, where's the source? Like, if there's this is, you understand that this isn't even a to do. This is literally an empty object with priority on it, right? But I didn't want to make the symmetry complex, because technically this would be coming from like a combination of source to do and previous state to do, and you know what I mean. That's my hypothesis here, that store derivative is a function of rotating. It mutates the current state. That is my hypothesis of what a mutable projection is. As it gets reactive, like, there's nothing it's tracking here except priority, but as it got reactive updates, it would mutate it to the next state. Okay. I've also named them differently because these are named differently, so I named them differently. I didn't call it, like, it was so that I can keep the same symmetry. How would if you wanted a derived value that was mutable, that you can mutate? Yeah, I didn't put it here, but they all take an initial value, right? In the case of signals, it's the first argument. And in the case of createMemo and createProjection, it's the second argument after the function, right? So, yeah, where are we? Right? Right. Like, initial. Like what I'm actually playing at here is there is a complete symmetry between what I'm trying to talk here. Okay, Writable. We talked about create Writable forever. I'm calling create Writable memo and create Writable projection. Honestly, I'm not sure I like the Writable because I'll explain why in a minute. But the idea here again is you know, you would take some immutable data. I put previous here just to show that it's there, but generally with create Writable, you take some immutable data and then you override it essentially. And with the create mutable, again, you take some. Here I'm using a mutable source, so I'm like diffing it to show the mutation. But reconcile performs mutation. It's not the next state like this one here. It's actually applying fine grained changes. It's applying mutations, right? Like even though this like under the hood reconcile mutates things. So mutation, pure derivation, right? Like immutable. Okay. See, I started thinking about this because in a sense, I'm not sure if I intentionally gave the name signal stores different names so you can see if they're different throughout. And part of me wonders if writable prefixes is obvious for the intent as just calling it derived version of the source. Because like this is one of the things, like, is this a writable memo or is it like a signal that is derived or a store that is derived? Like, because most of the time when you're going to want to use a writable memo is when you want to create a signal essentially that's derived from something else, or when you create a store that's derived from something else. So like I think that my naming might be backwards. Like you might, like, I don't know, this is a naming mess, but I just wanted to show the symmetry. Okay, this is the fundamental difference between signals and stores and between memos and projection. It has a significant impact on how these primitives are used. Immutable changes always constructs the next state, and mutable changes mutates the current state into the next state. Immutable change is consistent in its operations as it just needs to build the next state regardless of what changes. Mutable may have different operations depending on what changes. Immutable changes can always has the unmodified previous state to work with, while mutable changes does not. It leads to some edge cases where shared data, like using things in reconcile. Mutable is tricky because you can't always just use the previous state to make your decisions. It's like this thing that you're building. So with all this in mind, let's return to diffing. Okay, we are pretty good with the mutable derivations. I think mutable derivations are underexplored. The challenge in these APIs for driving generally involve a single function that reruns on update. Since you aren't staying with the same source like one would with immutable data, and the whole goal of using these mutable structures is more granular incremental change without diffing, how would this function ever do things differently? What I mean is, this example here where I have the, sorry, I should go to the eye view. It's easier to see. This example here where I have the create projection where it's like writing this, every time it runs, it just only updates the priority. How can we do different mutations every time the projection runs? Question about PPR. Yeah, I mean, I don't have anything specifically on PPR. Oh, it's funny. This article actually might be good. Do I talk about streaming in it? No, I don't talk about streaming in it. Was it? Yeah. I mean, the problem is like, there's a lot. I'd also check out my what am I looking for? Not that. Sorry. I'd also check out my SSR server. It's not on this page. Next. Server rendering in JavaScript, optimizing for size. Yeah, YSSR. Yeah. This series talks about the types of. It's good background for this whole stream. Actually, it talks about like performance profiling based on size and like timing. Partial pre-rendering is basically streaming plus static content. Anyway, but yeah. So, anyways, my question is, how will this function ever do different things? The first option is you don't, right? So, like, pretend if you had to create memo and it was immutable and you wanted to add properties to it, you would do this every time. You'd spread the current to do, and then you just add the properties to it, right? Technically, with createProjection, you could do the same thing, right? You could just assign the new properties for it. If you assign multiple signals inside the frame. Well, what I'm assuming here is that if the value doesn't change, it won't notify. So if priority stayed the same or title stayed the same but done changed, only to do with priority.done would trigger down here because you're just applying the same value over and over again. So you see that there's already advantage over this where this one doesn't know what has changed on it. So like anything that listens to do has to do with shallow diff. It has to go, oh, has priority changed? Has title changed? Like down where you use it. Here, the diffing happens at write. Here, the diffing happens on read, right? Difference is this notifies the one thing that's changed. This notifies everything, and then they have to check what changed, okay? Right. But is this not really diffing? My point is that it is. Each value has the previous value. When you set it again, it sees it's equal and does not notify yet. So yeah, I like my simplification. Diffing on read notifies everywhere. Diffing on write doesn't, right? The fact that this is diffing gets even more obvious the deeper the data goes. How would you granularly update an array? You might create a new array of the same object. You might try to alter existing array by looking at the indexes and comparing values. You have to be careful the order you do stuff because once you mutate part of this data structure, there's no previous state that you were looking at anymore. If you want to keep it around, you need to deep clone it. So ideally, when incremental changes happen, your computation function would do different things, which means the source needs to be incremental. Now, don't get me wrong. I'm not saying we force this. More, it only makes sense to use certain primitives when certain conditions hold. If you have some sort of derived mutable thing, ideally, what would cause it to update would be some set of mutations you need to apply. If we brought back our Trello example, we want our computation to do the blank. So this is the least, if you've been following the last few weeks, this is the least complicated version of this Trello projection I've probably done to date. But the idea was, if we created a board that had basically a timestamp, okay? So we're just going to do this, right? We're going to go previous timestamp or 0, okay? And then set the timestamp to now, okay? If we had a way of knowing if something had updated since the last run, I haven't figured this out here, but just put this out here. So if we knew whenever the board coming in, I'm sorry for people who haven't been following the Trello example that I've been going over the last 3 weeks. This might not make as much sense, but the idea is you have a board, you have optimistic updates. So you have the board that you get from the server, you have optimistic updates while it's in flight, and you want to combine them so you can show both the board where it is and the optimistic updates. But then when changes come in, like more optimistic updates, you can continue to update that board. And then when the server finishes, it can then reset it essentially with the server pieces and maybe even apply some newer changes that came on. And the problem with this that we've been doing to date is it's involved a lot of diffing essentially, because I went through a whole thing of looking at Signia incremental computed to do diffing. And what I realized that if we take this principle of basic data, as long as we know when the board resets, this is the create async call, like the server data upset resets essentially. When this happens, we can, if there's basically the first time we're running this or the board is updated, we can reconcile, i.e. diff, and apply our mutation. So basically what this is doing is it's cloning the current board and then applying our list of mutations to it and then calling reconcile and diffing it. So initially, diff is easy. It's empty. Like if you're starting with nothing in the board and you diff it right away, you're just going to immediately populate it. There's not going to need to be like a whole bunch of fine-grained stuff. But it does mean that later on, when the server updates, it's the one that caused this to rerun. Then we can basically take the new reset version of the board, apply any remaining mutations that are there might be 0, doesn't matter, and then diff it against the current projection and then update the current projection. So only things that change. That means if you have optimistic updates that then became realized in the final version of the board, you actually have the same reference in this projection. You don't actually have to re-render something. So if you, it's actually kind of cool because you can basically, it will see no change. It'll go to write it in the same way this was going to write it and see that there's no change. So instead of diffing everything down the line, it might actually realize that when it reset the board that there's no change and actually notify nothing. It's like in the best case scenario. But in any case, when new mutations come in, you take the previous version and then you filter out all you only grab the newer mutations that happened after the previous timestamp and apply them. So what this means is as new optimistic updates come in, you apply them one at a time while you're mutating. You don't reset, reapply all the mutations and diff. You literally do fine-grained updates. And then here, when it resets, you do the diff and apply fine-grained updates. This was the problem in my last example. I was diffing every time. I was diffing here and I was diffing when we were doing each mutation. This doesn't diff by default. You have to call the diff essentially. So like notice we aren't using diffs in the Signia sense. We just need to know if the board triggered the computation. If so, we reset and force to reconcile. Otherwise, we just take our mutation and filter them to apply only the new changes. In a sense, diffing our list of mutations is another step of indirection. The easiest way to produce different logic here is filtering of instructions. You need to communicate the instructions anyway, and communicating the diff is just extra overhead. This is a lot simpler solution, and it's more performant than any of the ones we've looked at so far. So, gist of this is, this has the least amount of code, this approach. It doesn't require a special reactive system like Signia. It doesn't require a diff format, and it does exactly what you want it to do. It does incremental fine-grained updates on optimistic updates. So it doesn't like reapply them all. It just applies what changes. And then when it resets, it keeps reference when it does a diff. So it's quite possible that it actually updates nothing after the reset. So yeah, no special reactive system. All we need to know is this idea of, have I updated since the last time this computation ran? So yeah, I'm pretty happy with that. I don't know if anyone's been following this, but I'm hoping, especially if people work on the Trello, they understand that this essentially, I think, is the solution. It does look a little bit like the Signia solution, except, where you're like applying mutations and stuff, but it doesn't have any of the weird overhead. And it basically forces you back into fine-grained as quickly as possible. Yeah, this is the key. We need a way of asking in any computation, like, hey, have I updated since the last time this thing ran? I think this is a helper that should probably come in to Solid in general. Anyways. Okay. But too early to pat ourselves on the back. I was thinking the first thing people think when they look at this, why can't I just use create or factor create computed as I've been? Every time I go back here, I feel a firmer grasp of why derivations and correctness are important. Laser derivations are the first thing. Yeah. So yes, we still need a clock. Yes, that is the key. Solid has a clock today, and I would like to keep it, I think. Yeah, I'm missing the rest of the code here. Give me 2 seconds before I go into the next thing. Drive. I think this one is the closest one to this. Basically, right, because I have all this weird board state garbage. Maybe I should do the other one. But essentially, there's a create async call that fetches the board from the server. And then apply mutations is like a thing that basically takes a list of mutations and then like kind of like applies the changes. Like goes, oh, if it's create note, push the note on. If it's a move note, set a note at the index or whatever, right? And then, yeah, and then the mutations themselves are a memo that reads from a bunch of used submissions. Basically, I'm using actions and solid start as an example, or from the router as a way of like getting optimistic updates. And then it looks at those and it creates that list of mutations that get handled here. The code's a little bit all over the place, but essentially, when you get back to your derived value here, what's triggering this is it's reading the board. It's actually reading the board here, which means whenever the board changes, this reruns, and it's reading mutations here. So basically, when either, and here technically, whenever board or mutations updates, this computation reruns. The output is basically like a store where each update's applied fine-grained. Yes, I did steal your code. I used this as the basis of this. Benton was working on the Trello demo and too cleverly, figured out how to make this work. Basically came to the same solution that I would have come to. But it occurred to me when I looked at it that I don't know if everybody would have been able to figure it out. And when I saw it, I saw two things immediately. I saw that I could make it more optimal, which is what I'm talking about here. And I could also tell that this was tricky to do in a way that's going to support derivations. So this is why this approach has been so pivotal to me kind of working through this problem. Yeah, it bugged me how hard it was. Like, this should be just basics. Sorry. Yeah. Okay. So let's get here. Why derive? Lazy derive, right? I think you guys have seen this kind of scenario before where you have A and D and B and C. If A and B update, they both notify down to D. So when it runs, it knows that C has potentially changed. And then basically when D runs, it knows that it needs to like look at C and look at B, right? This is why we derive, right? If we didn't derive, if we did like create effect, like to write, basically if we had an effect that said whenever B set changes write to C, like then when D ran, it couldn't know, like basically if A and B ran, there's no connection down to D. Basically D could ask for A and then essentially still see the old value of C because it doesn't know that B is updated. Whereas if you do it derived, we can actually trace down, right? But we've covered this in the previous stream. Another problem is, what if B is async? What if this is async? The effect will wait until it is present to set C, but D will never know it has an async dependency. This means it will never suspend if it's in a different part of the UI, essentially. Because if we use create effect essentially and we don't connect this tie, again, A and B update, D is not aware that it should wait. So it just grabs the old value and updates immediately. It's basically stuff like suspense could never happen. So it's not only because of lazy derivations, but async propagation is another reason why we have to derive. You know, because the only way it would ever, like, if B is async and you do an effect to write to it, it's actually reading the async value right here instead of reading it where it's ultimately going to be used in D. By reading it here and then setting the value here, this is actually what suspends, not this, which means that, like, if it was a different part of the tree or something, then the like D's never going to know and it's not going to suspend. And yeah, as I was saying, it might trigger a higher suspense boundary. Like, if this is in a lower suspense boundary and this is a higher suspense boundary, using create effect here to read it basically stops the propagation of async right there. Okay. Another realization that I had was that everything is potentially reactive with colorless async. It's kind of similar idea. This is a good part to quiz you guys on a bit. If you guys are still present, consider the difference between on mount with split and a create effect with a split, like split tracking. Because for those who know, unmount is basically an untracked effect, but there's actually a pretty big difference you have to consider here. The first thing you might be thinking is, if it is an effect that doesn't update, we've untracked the read, it is basically the same as on mount, but is it? Depends on how it's implemented. My first inkling is on mount would actually be implemented like this, where it has no reactive tracking part and it just runs the scheduled function. That's where I'm getting to. That's where the difference comes in. You have nothing to do in the pure phase and you just tag this on the other side. This is a subtle difference from untracking data in the pure phase, like I've shown above. What if data is async? Now one could argue that it should behave the same, but if the pure side effect can't run to completion, it needs to run again until it does, because there could be other tracked things after it. So what I'm saying is, like, if data throws, you need to run it again to know that, like, in case it's like untracked data and user. So if data throws, you actually have to run it again, which means if you put it in the second side, it's too late to run it again. You can't. So there's a huge difference between untracking on the read side and scheduling something on the effect side, because even though this is, untracked, because this is async, it could run again, because if it throws, it needs to be able to run again. So the difference, yeah. So what do I say now? Okay. Which means that the async dependency is a temporary one until it runs without throwing. So the difference is the effectful side will run once when the data is loaded. The first time console logging the loaded data. The on mount will error out without logging. It has no reactive context to rerun. Yeah. So what I'm saying here is, you shouldn't read from async data in an on mount. Essentially, like, you shouldn't read from reactive values in on mount at all. In fact, if you think about it, potentially, which is making on mount a little bit awkward, because this one, the way it's implemented here, would literally just throw and just error and not rerun. And this one would rerun this until it could resolve and then run this when it was finished. So this one would work exactly like you expected. This one would be broken. So I don't know. The problem is, it's impossible to implement on mount, I think, a different way, because this data unless you put this whole thing, unless you made on mount this whole expression in the tracking part untracked, it couldn't work in any way. But if you did that, then this happens too soon. The effect should happen not on the pure half, but on the effectful half. Yeah, I mean, No, but we don't want is loading. The answer is on mount is poorly designed, or the answer is more, which is probably why React doesn't have on mount, or the answer is, well, let's keep on seeing if we have more answers. There's another argument for splitting effects. You can't interrupt the effectful parts of effects without erring because they could have already affected the world. It's also an argument on why unmount is a desirable printer to have, since it might lead people to make this mistake. Or it might be an argument for warning when reacted data is accessed under certain untracked contexts, like I showed in my strict mode stream. If you guys remembered, I had one where it errored out if we tried to access like a signal top level in your component. It's possible that we should just say, like, don't access signals like that. I know this is inconvenient, but I've been trying to think of the use cases for on mount anyways, where you want, it's like basically saying you force the person to call untrack here themselves, right? Like if they want to read it, they have to acknowledge on track. That was what my strict mode thing was. It was like, it's fine as long as they call on track themselves, but they shouldn't do it accidentally. Okay, similar example. Let's look at this one. What's the difference between these two? Create a signal and initialize it with some prop you get. Create writable and initialize it from a prop, but untrack that prop read. See, obviously, we know there's a difference between create writable and create signal, because the whole point is that whenever the prop changes, then the base of the signal changes. This one could never update, right? But I'm purposely untracking it again. What's the difference? You might look at this. Right. This is what you guys think, but I actually untracked it, so it shouldn't react. Are these the same thing? Again, what if prop count would become async at some point? Well, now in a sense, it's the reactive value you can listen to now. You wouldn't want the count to initialize as undefined if you expect it to be a number. So it does rerun if it's async. Yes, right, exactly. This is very important to understand the implications of what we've been calling colorless async. Everything is potentially reactive with colorless async. Okay, see, this is the header of this section. But I really want to drive. You have to decide if this is worth it. Do you understand what I'm getting at? Because think about what happens now. What if this is async? This would throw right at the top of your component and throw right up to the next decision point. It throw up to the next show component or conditional in your JSX and go all the way up the component tree to the reactive memo that hosts it. Right? Like if you had basically components render once in solid. It's like when a switch changes, you go show this page, suddenly you render it. That's the next reactive context to this, right? Thanks, Fuzzy. Have a good one. So if this threw, it would throw all the way up to the decision, and then from that point, you'd have to re-render when it resolved that whole branch of the tree, kind of like React. However, with create writable, this would catch the throw and it would just propagate the async through. So wherever you use count in the DOM somewhere, that part would update. It'd be fine grained. Well, it's not a function for initial value. This is actually a computation. What I'm saying is create signal shouldn't. It's more saying that you shouldn't read from a signal top level in a component. Right? Props.count is a signal. If you want to create a signal that depends on a prop, you want to create a derived signal. That's why I was saying writable might not be the right name. Do you understand? Like the argument here is that you shouldn't. This is very strict mode thinking, but you shouldn't access reactive values unintentionally outside of a reactive scope. it's this thing again. Create writable memo, right? That's what I'm showing here, right? Like, or derive signal. This is why I thought the naming was wrong here, right? Because this gives you super fine-grained updates. This re-renders a whole branch of a tree. This is a drastic difference in behavior, enough that it's the same way components untrack top level. You almost want to make components not participate in throwing top level, right? I mean, there's different ways to solve this, but this is what I'm getting at. Like when solid untracks every component, if we didn't, and someone did this, then that whole tree would get wrapped up again, right? Like, because whoever was listening to it, like the memo under the decision, would track it. So when count changed, it would cause the whole branch. That's why we untrack every component. We, unfortunately, with async of this manner, basically apply that again. Basically, untrack isn't enough. Right? Like, there's a reason we untrack components. We don't want the whole tree to rerun. Async pushes everything to be potentially reactive. Yeah, but given the goal is to be able to have a single idiomatic way of writing your code, it might be better to just treat our ESLint rules as gold. Like, you know what happens if I take this example and put it in the playground? It's fine. It's propped out children here. Reactive variable prop children should be used within JSX to track scope like createEffector inside an event handler, or else changes will be ignored. See, this is why I'm bringing this up. This makes me wonder if throwing is the right thing to signal ongoing async work. It is the best. It is a great way. It removes the undefined and it lets us do hyper fine-grained reactivity. But it makes it like doubles down on our reactive rules. There's a reason ESLint complains about this, right? Like, I don't think everyone would be happy with such a change. I'm just throwing this out here that is this trade-off worth it? Right? There's a definite trade-off. What this is capable of when you follow the rules is something that we've never seen in a JavaScript framework. Arguably the most powerful async model imaginable in terms of being able to like smoothly propagate granular change without having to worry about null checks. But you can't lose reactivity, so to speak. Okay. I hope you see why I'm thinking less as writable memos, more derived signals, because you're going to want, when to make a signal in your component based on props, my hunch is you're less thinking memo, more thinking signal. Yeah. Don't get me wrong, people will overuse this, but it's clear answer instead of reaching for create effect. Want a signal that's based on a prop? Use a derived signal. Yeah. Yeah, pretty much. Anyway. I think the biggest thing here is there appears to be a consistent model out there, but it leads to us writing our code differently to today, similar to the splitting of effects into tracking side and effect part. I don't think people will generally be stoked about that, but it's not only enables things we couldn't do before, it actually is an explanation for why certain things worked inconsistently before. It highlights implicit assumptions we made that aren't safe to make. It is a corrected model, but pragmatically, our industry has learned long and hard that you don't fix what isn't broken, as that will always lead to misery. The message to treat everything as potentially reactive has been our assumed mantra for years. It was an intuition I had when I created Solid with focus on naked functions, but over time it has crystallized into explicit rules we can follow. This exploration suggests that it is a principle that can guide us through our most challenging problems. See, I took this as a positive, essentially, because the same thing that would make this fail is the same thing that, in a sense, in my strict mode stream, I was saying you shouldn't do. The same thing that ESLint is telling you not to do. It's actually consistent. It's just not expected, I think. Like if you split effects, you do this, you do all the things, you have a model that is as consistently true as React, but it is like, the reason this makes me excited is this shows that there is the potential for a model that, from an academic standpoint as well, from a pure standpoint, is consistent and doesn't break. Like React always treats every other framework like, oh yeah, you guys can do that, but that's like breaking the rules, or like it's not as consistent, or like basically it's like making some kind of compromise that makes it less pure. I'm arguing that this approach that I'm talking about appeals in the same way that the React mentality works, and I'd argue that it's even better. Technically speaking, it sounds reasonable, but I probably could throw away 50% of my code. 50% because all the null checks, right? Well, the thing you have to understand is, like, once you adopt this thing, everything becomes derived. You start using things like Suspense, and like a lot of the iffiness starts, like everything gets streamlined under this model, right? Like it's less code when you're playing within the lines. It's just hard when you're not, right? You'll be less likely to lose reactivity if we're like, no, don't do this. Do, this, like, you know what I mean? Like it all plays together in this consistent model. It's just, yeah, this is a very different zone. Yeah. Anyway. It's also interesting. It's like, this is not a path that like say Svelte would follow us on, I don't think. I don't know. It's interesting. Maybe they would. Maybe they make the compiler try and automate this kind of thinking. But like, the end result is very appealing from like a framework author standpoint. But I understand, having seen React struggle through similar things, why that might not appeal to everyone. Anyway. Yeah, I didn't expect the rain because of music. Yeah. Yeah, I mean, you have to think about how to handle it, I guess. Anyway, I'm pretty much done. I don't have a ton for this week in JavaScript. I'm going to try and condense it really quick here. We covered a lot of stuff today. I knew we would. But let me quickly get set up here. But I don't think I didn't have a ton of stuff. Yeah. Where am I? Just a second. Bookmarks, my profile, and then Solid. Okay. Let's do this. Any framework that you haven't actually used yet but want to? Not at the moment. There's a couple up and comers that have some interesting features I want to look at. But generally, no, not at the moment. I mean, I feel like I got an idea from live Vue.js at least. Okay, let's go this week in JavaScript. Shortest one ever, but let's just do this. Where is it? There we go. All right. First thing, I'm just going to go over some bookmarks because I thought these appealed to. They were interesting to me. Astro, again, talking about putting script tags in to do stuff. I think it's good that they remind people about this because it is just HTML. In a sense, like what I was playing with today when I did that whole streaming hydrate script was me just like inserting script tags into HTML and just doing like some separate JavaScript. If you want to hack ideas, you can do this. If you have a simple site and you just need a little bit of interactivity, go for it. I'm glad. I mean, this is kind of obvious from an Astro perspective, but I think a lot of people, and I'm very guilty of this, forget to talk about the features the framework have because they seem kind of obvious, and then people are like caught by surprise. Like Sol and Sol Start have an incredible amount of features, stuff that you might not even find in other libraries, incredibly powerful things, and I always forget to talk about them because I've been working on them for 3 years or whatever. But like sometimes these features, like 5 years later, you're still like, wow, I can't believe that they did this. So I'm glad that Astro is like putting focus on simple things that can help people. Remix releasing their headers library is actually really cool. A couple of years ago, I would have loved to just steal it, so to speak. If it was open source, just bring it into the project. We've had to build our own. I think everyone's had to build their own. So it's cool that they're just open sourcing like some of their internals from Remix so others can use it. I'm actually very stoked about that. Oh, did they release Fog of War? That's the lazy route detection. I hadn't seen that they released it, but that's cool. As experimental. Yeah, I mean, it's a cool approach. We've been talking about it because the size of a manifest, and I've been focusing a lot on HTML size. But yeah, no, it's definitely interesting. Let me get the banner out of the way here. We already talked about Multi. We talked about Matthew Phillips. Yeah, Stack Overflow survey. Obviously, Svelte did very well on the like up and comers list. Beat out by 0.1%, I think, by HTMX. And live Elixir, apparently everybody wants to use Phoenix live view. I'm gathering it's like very high on like the up and coming list. The reason I'm pointing this out is this is the first time Solid's been on the survey in 2023. I don't think we were on the survey, to my memory. So I'm actually pretty stoked about that. Web frameworks and technologies. It's fine. Why am I not seeing anything? Okay. There's like several categories. I just need to find. Yeah, admired and desired. This is what they're looking at. Yeah, web technologies. Now this is. It's an interesting flow where they show like where the stuff sits, but like admired 62%, desired 33.4%. Svelte admired 72.8. It's very high. Desired lower. So I'm gathering this is around like actual usage. Like React is still highly desired, but it's a little less admired. The big ones, the ones that are standing out on the admired side, obviously ASP.NET Core. I didn't realize that was a big deal, but it apparently is. Svelte, HTMX, Astro, Solid, Phoenix are all the ones that have over 65%, basically. But yeah, as I said, this is cool. This is the first time we've actually kind of like made a blip. We're actually more desired than Phoenix, which is funny. This was an interesting one for me. Remix is down here, where it's both less desired and less admired than us, which is odd for this. Like you can understand why Angular, for example, is less admired, but higher desired. But or so that's JS, but you know what I mean, in this range. But like, this is an odd place for Remix to be, I think. I don't know. Maybe just like this isn't a widely front end crowd, I guess. Like, I don't know. Like, I'm surprised Solid actually showed up here. But yeah, I don't know. It's interesting. It was a first for us. Obviously, Svelte has moved up quite higher on the desired scale, which is really good for them. And it looks like Astro is kind of getting out a little front of us too, which they should. Astro is amazing. But yeah, interesting anyways. A lot of people talk bad things about Remix without people even trying it. Yeah, it's interesting, like where that perception comes from. Yeah, they sorted by admired. Yeah, I mean, if they sorted by admired, it would be, it'd be, what would it be? It'd be Phoenix, then HTMX, then Svelte, ASP.NET, then Astro, then Solid, then Fast API. Yeah, we'd be like fifth or sixth. Yeah. Yeah, where Next.js is right up here. Yeah, no, very amazing job of beginner friendly, and you could argue that Svelte has been as well, and Vue. Maybe this is where this survey actually takes more, has more impact, because I was talking about how we aren't talking about, Svelte or Vue as much on the stream. We talked about the signal stuff, obviously, but like with the stuff I've been looking at here, things of that category seem to be doing much better. Anyway. Yeah, I think the big one here is Astro is just passing out Nux and is catching up to Ruby on Rails, which is crazy. How is Blazor up here? God, I just don't understand. Like, this is like the only chart in existence where Blazor isn't dead last, I guess. Yeah, I'm confused. It's tricky because there's really good people working on it and smart people, but like anything technical and really cool things they're trying to do, but it's just like it's like the ultimate example. You know how I criticize React of being like good ideas sometimes, but the implementation fails. Blazor is like the epitome of that. It's like the implementation like couldn't fail harder. Anyway, that's it for bookmarks. What else is new? Oh yeah, I'm loving seeing other talks going up. This is so freaking cool, to see other people talking about Solid and Solid Start, especially because I haven't been doing as much. People are asking, oh, what's a good thing to learn about Solid Start? Don't look at my content. Look at Atila's content here. That's probably the best way. I teach Solid the same way I teach these streams, right? Like, even when I'm doing a talk, it's like for the concept of it, like why I built it that way, how that's powerful. If you want to actually like be like, what is it like to live with Solid Start? How it's like to use it? This is where you got to go. Yeah, there you go. Thanks, Dev. Yeah. Spirit-led software. Yeah, this is cool. I was talking to Jacob, and he was like, "Oh, Solid probably needs a clerk thing," and then he went and looked, and there was already one made by the community. Clerk has been pretty easy to integrate, which is really awesome. I'm just super stoked to see, like, again, more libraries. Oh yeah, that's an interview I did. Again, Dev doing great work. He did one of Jason Langstrom's coding challenge things, and he built it with Solid, which is very cool. I haven't actually got to check this out yet. It seems like a cool concept. I remember when Jason was pitching the show right before he left Netlify. It was really cool. Courses. I bet you this course is better than my ability to teach you Solid. So seriously, don't. I'm not the best person to teach you how to use Solid. I'm just gonna say that right now. if you want to understand web development, you want to understand the fundamentals, want to understand the details, then yeah, come. But I'm so happy that there's content made by other people that's probably way better than any content that I'm making. Is Solid Start 2 in development? No, but we're working towards Solid 2.0. I switched to YouTube to chat. There you go. Where is it going to be, Dev? AI Dev Summit. Interesting. Okay. But yeah, very, very cool stuff. And finally, to end this off, I think everything that I've talked about, I talked about on stream. This whole week has been Astro week, or last week was Astro week. So that was basically what I was looking at. Obviously, Netlify Astro partnership, big deal. This was the partnership that should have happened ages ago. I'm glad to see it happen. It's like, since I got hired on at the very beginning, I was like, I understand Netlify's, customer business model kind of stuff. And like Solid could appeal to a certain portion, but Astro was like the no-brainer. I'm glad to see where things have come. I've been trying to push, like, before the Gatsby integration or buyout and all that, and that was for a different reason. But like, I am very stoked to see this close link between Netlify and Astro. It makes sense. It's the, like, all ships rises. They have the cultures of both of these companies are almost identical. Obviously, durable caching platform, primitives. Like, Netlify had a lot of really good announcements this week. Astro had a lot with server islands. We've talked about all the stuff, I think, about server islands. One little snippet that might have missed. You remember the build output API from Vercel? I loved it, talked about it, worked, testing it. Netlify has always had like a file system routing, but Eduardo from Netlify team has been working really hard on this, making this into a standard. So things like blob and edge functions are all just like where you put it. It's, as I said, a very similar concept to what you have in Vercel, and you've been able to do the stuff in Netlify to a certain degree before, but now it's like becoming an official thing. I've been stoked to see this, honestly. In the last couple of years since I joined Netlify, there's been like little bits here and there of stuff, but the company's been rather quiet, focusing, on a lot of, internal stuff, a lot of like enterprise stuff. This is the first blast that I've seen of this nature from Netlify really since I started. And it's cool to see them, talking about really relevant stuff, shipping really relevant stuff. So very, very cool. Yeah. I mean, as you can tell, I spent all this week building those prototypes and benchmarking stuff. I thought I was going to, do other stuff, but then like before Astro drops the article on server islands, I get hijacked to testing it, and then I just started going crazy with stuff. I got one other piece of news, solid news, I think everyone is going to appreciate who uses SSR in Solid. Just a small little gift. We've shrunk the size of the data HK. Now, this makes about a 1% difference on your total size with compression. It basically has a zero performance aspect, but it makes your code way, way easier to read when the keys are that much smaller. Yeah. Just it makes people happy. It makes me happy. Yeah. Anyway, I think we are good for today. Thank you all for joining me. We talked about a lot of really cool stuff. I'm going to have to really sit with all these changes in Astro and kind of think of how this shapes my perspective on things like RSCs, how, like, really it's challenging what I think about how web dev, merging is going. I actually, in one hand, people think, oh, maybe this means things are getting closer. I actually think this is getting farther because they've really raised the bar, and I see a lot of potential here. Anyway, yeah, thank you all. Have a good one. Yeah, and yeah, I think the derivation stuff. I mean, I don't know if I can convince everyone on it, but I think there is a sound model here. Anyway, I'm excited about that too. I mean, there's so much to be excited about. Have a good one. Have a good weekend.